Okay, so here is ETABs. When you open ETABs, it's gonna show up something like this. Same thing that we did for SAP 2000. You are gonna say File, and you are gonna have a new model. All the tabs are deactivated because you don't have a new model in the system. So I'm gonna say new model. If you guys remember in ETABs, when you say new model, it's gonna ask you about the units, about if you want to start with typical things. Same thing here. Because even now, it's heavily used for design. It asks you about what units that you want to use. So I'm gonna use the built-in units. I don't want to use the user default settings. I'm gonna use built-in settings, and I'm gonna use units that are metric. If you want to decide on the region, I can decide on the codes that I'm going to use for design, but I'm not going to do design with ETAB, so it doesn't matter much for me. So if you want to pick like ACI or AISC for steel, so you can choose whatever. All what I care about right now is the units. Then I hit OK. So once you hit OK, it's going to ask you, because usually SAP 2000 doesn't have truss, doesn't have tanks, doesn't have stairs. It's only buildings. So it asks you, what is the slab system of your building? Like, you want to pick a plan, like you are going to do everything on your own, or you want me to develop some grids for you to help you drawing, or you want to like start with one of the slab system that I have. Like I have a steel system for a slab. I have a staggered truss for a slab. Staggered truss is something like you guys, when you go to big stores like Walmart, Publix, look at the roof. It's like trusses. That's how the slab system of the truss, or the roof system of the truss. Truss, it's like a rib, and the rib is a truss system, and they are at a specific spacing. So that's kind of like we can call it a truss rib slab. Here we have a waffle slab. Can you see? And this is a two-way rib slab. So you have a rib here and rib here. That's a waffle slab because they are very closely spacing. This is flat slab, and I can see a drop panel in the middle. You can make the drop panel 0, or you can make a drop panel with a specific setting. Here is a flat slab with a perimeter beam or a marginal beam, like the one that we have. We have a flat slab with a marginal beam all around. This one doesn't have a marginal beam. I can see the beam. So what I'm gonna do, I'm gonna start with grids. I'm gonna do the same thing that I did for SAP 2000. Let's see how it's easy or difficult in SAP 2000. But also, the software gives you like the option. Do you want me to start with a specific story height? You can give me the number of stories of the building. Once you import, like if you said I want 10 stories, so it's gonna prepare the grid system or the slab system that you want to start with. Here was the number of stories. Like let's say I picked flat slab and I said I have 10 stories, it's gonna make a building flat slab with 10 story right away. So I'm gonna start with one story because I only want to do one for now. And the typical story height, if you guys remember from last time, I'm gonna make it 3 meter or 10 foot. So and actually ask you about the bottom story height, and this is because usually in tall buildings, the bottom story is the height is much higher than the other typical stories because that is the podium of the building. So let's start with grids. And I'm gonna say that the number of stories is 1 for now. I can change it later. And the height is 3 meter, and the height of the bottom story is 3 meter. I'm gonna say okay. So here is gonna start a new model. So I'm gonna wait a little bit until it finish. And actually, before I start doing anything, I'm gonna change the units. So I'm gonna come here to the units. I'm gonna make sure that the units are okay with me. It's millimeter. No, I want it to be meter. And the units here is ton force. I'm gonna make it ton force. Here, I can change the units. All right, I'm gonna do something really quick. I want to customize. The thing is, I forgot, I asked him to do uniform grid spacing. So he basically developed these grids. Like I say I want a 1 story, 3 and 3. So that's everything. But the thing is, he started with grids numbers like he started by 4 grids in X, 4 grids in Y, and the spacing is 6 meters. The thing is, I want to do my custom grid spacing, and you can come and edit them here. Okay, so this is same thing like ETABs. If I, like, let's say cancel, and if I said I want a uniform grid spacing, or I did it by mistake and I hit OK, you can come after he does that and click right click on the screen like this, and you say I want to add or modify grid system. So the thing is, he divides the grid's definition. If you guys remember in SAP 2000, it was X, Y, Z. Here, he divided the XY system from the floor system. And right now, there is no Z, it's a stories. So here is the grid system for the XY, and here is the grid system for the Z direction. And if you have 10 story, they are going to show up as a 10 story here. So let's do modification to the grid system. So I'm going to say modify and show. So actually it's showing me the grid system that he started with in the X direction and the Y direction. I want to modify that. So if you guys remember the grids from last time, I have 0 and 2.75. Let me remember. And then I have 7. And after 7, there's 5. Okay, there's something cool here. And actually, that's much easier. You can display the grid data in ordinates or spacing. Like if you know the spacing between each grid, you can put the spacing. Like I don't have to accumulate, 2.75 and then 7 and then fit 12. So you can do that, or you can make the spacing. So actually, I remember the ordinates. So I'm gonna leave them as ordinates. So it's 7 plus 5 is gonna be 12. And then I'm gonna add more. 14.5, and then 17, and then 22. This is 22 plus 7 is going to be 29. So the last one is 29, and 29 minus 2.75, so it's going to be 26.25. That was the grid in the X direction. Let's make the grids in the Y direction. So I have 0, same thing, 2.75. And then I have 7 plus 5, 12, and this is 1 meter. Okay, 7 and 12, 13, 13 plus 2, 13 plus 3 is going to be 16, and 1 meter, 17. So I have here, this is 7, 12, 13, 13 plus 3, 16, plus 1, 17, 17 plus 5 is 22. And I have 2 more grids. One of them is 29, and the other one is 29 minus, so it's going to be 26.25. All right, so that's all the grids that I have for now. So I'm going to say okay, and I'm going to say okay. Wow. I don't know why. Oh, actually, it sounds like we messed up with one grid. It's over there. Let's see. Modify. Let's see what happened. That's the Y grids. Oh, so I have one here that is 275. I don't know how that happened.
You need to label that 10.
You can make it 10. Say okay. All right. So now it makes sense. All right. So this is the same grid system that we have from last time from SAP 2000. Let's see what is next. Do you guys remember after we drew the grids, what did we do? Define what? Materials. So I'm gonna go define materials. So you'll come here, you will find lots of materials, steel and concrete. So the first one I see here is steel. If you are gonna have a steel cross sections, you can come here, change the F yield or something. It says a steel. And by the way, the units that's showing up to me here is kilonewton per meter cube. So if you wanted the units to be ton, so you have, actually you can, I believe it changed all right, let's go to units and make sure that our units are customized to meter and ton force meter. And then we go back to the material, define. I make sure that the unit here is a meter. Okay, it's meter. Define, modify. Coming here, the units are changing. So we have the steel is 7.8, which is the most important part, Poisson ratio is 0.3. So I believe most of the things that I need are there if I'm drawing a steel cross section, the Poisson ratio, Young's modulus, and the steel weight per unit volume. Same thing, the concrete, we have the 4,000 pound per square inch concrete from last time in SAP 2000, same thing. The weight per unit volume 2.4, the Young's modulus, Poisson ratio. That's all what I need right now. If you are gonna do design, so you have to input the design property data. So they make it here. You can include the concrete compressive strengths or the characteristic compressive strengths FCU, and you can include the value of this here if you are gonna do design. And usually we use ETABs for design too. It's a very powerful tool in design. And then finish, you say, okay, your materials is already saved there. Same thing, define sections. You can go define frame section. So here you can add new property. You can pick either concrete, steel. There's a lot of materials here. So I'm gonna say, I'm gonna pick beam and rectangular beam. I'm gonna say beam 25 by 70 centimeter. And the material is concrete 4,000 per square inch. I'm gonna change the depth of the beam to 0.7 and the width of the beam to 0.25. And then I'm gonna hit okay. If you wanna change a modifier for the beam, if you wanna reduce the stiffness, increase the stiffness, and at some point when we do seismic, we reduce some stiffnesses, but this is where we are gonna do that. Let's not like focus on this now. We are gonna talk about why we reduce the stiffnesses for cross sections later. But if you want to reduce the stiffness, you go to set modifiers here or modify modifiers. And then I have my beam here. If you want to add a copy of this beam or you want to add a new property, you come here again and then add the new property. Let's make a column C1 50 by 50 centimeter. And I'm gonna change this to 0.5 by 0.5. And if you want to add another column, you can add a copy of the property. And let's name it C2, for example, 0.25 by 80 centimeter. So if you want to change this, let's make the depth 0.8 and the width 0.25. And I'm gonna say, okay, this is an example of how to do the cross section. Your cross sections are gonna be with a bunch of many cross sections. Some of them are steel, some of them are concrete. So basically, ETABS is helping you and giving you one of the most popular cross sections out there. So if you want to pick from them, you can pick from them. Yeah. This you have to define a material. If you have a lightweight concrete, you have to define a material. It's called lightweight. And then the weight per unit volume is going to be changing. The regular one is 2.4 ton per meter cube. The lightweight, you can go down up to 1.5 ton per meter cube. So you have to define a new material for that. And in tall buildings, maybe we will do that. Like maybe your structure is heavy and you want to decrease the weight. We usually use lightweight concrete in the slab, and we use ultra high strength concrete in the columns.
But if we just like a lighter concrete, wouldn't the roof of the higher stories, wouldn't they be like shaping more?
Why? The thing is, you are decreasing the masses that makes the building make this. So decreasing the mass is gonna decrease the deformation. All right, we are gonna talk about this later when we study the dynamics of structure. All right, I'm done with the material, so I'm gonna hit OK. I defined materials and sections. I defined the frame section, so I have to go and define slab section. By the way, here it divides the slab from the walls. Like back in SAP 2000, we define all of them as shell, but here he's specific. Do you want to define a slab section or wall section? So I'm gonna define slab section, and I'm gonna add a new property. Let's call it, it's a slab 30 centimeter. And same concrete material, and I'm gonna name it here. They name them, like you will not find shell. Actually, here is the shell. Usually our slab is shell thin, not thick and not membrane and not layered, because we don't have a steel layer or something. It's one homogeneous material. So I'm gonna say shell thin, and it's a slab section. And by the way, if you have a drop panel on your slab, we talked about flat slab was a drop, you can define the drop alone. All right, so I'm gonna change the thickness to 0.3 meter, and I'm gonna hit OK. And if you wanna actually add a new property, I'm not sure if we can find a wall here. We can find no walls. All right. So I define the slab, and then I'm gonna say OK, and I'm gonna define a wall section. I'm gonna add a new property, and let's say we are gonna make it wall 30 centimeter, and same material, and the wall is gonna be 0.3, and it's shell thin, and that's only one section. We don't have to do anything else. I define the walls. Okay, do I miss something in the definition? Beams? Showing animation, please stop it. All right. So we have columns, walls, slabs, beams. We define everything. Okay, we are done defining sections. What is next? Load patterns, right? Do you guys remember that load, live load? So here it defines two load patterns for you, not one, like ETABs, define dead and alive. And you will find out that he has already the self-weight multiplier 1. That means already it's going to calculate the dead load for you and put them in the dead load factor. By the way, this is only the on weight. We have flooring loads on top of the dead load, so we usually need to go to the code according to our building occupancy. We need to find out, depends on the type of floor that we're going to have, how much flooring load we should put. Okay.
If we not re-veneer of the structure, like say they first start building, is there like an option to put it or?
You can make, you mean like walls and interior walls? Break walls?
No, re-veneer is like so you have like the facade of the structure, or you have like the,
Well, if you have a facade that is really heavy, like glass or something, you have to find the load of this glass and what is the supporting system. Is it resting on the slab, on the tip of the slab? So you have to put it as a line load on the slab, like on the whole structure. So the facade, for example. So you have to account for every load on the structure. Like if your structure is like this, and there's a facade on this structure outside, and this facade is resting, for example, on a column or on a slab or a beam here. So this slab is going to take the facade load from here, and this load we're going to put it as a line load on the tip of the slab.
Okay.
And usually in when we have structures big like this, assume that this is the floor system. Usually the live load is not uniform on the floor system. Like if you look at the ES 716 for live load, they will tell you, okay, if you have a room that is a storage, it's gonna have different live load. If you have a corridor, the corridor is much bigger live load. So we have to divide the slab into pieces, and every piece is gonna take its own live load. So if you look at one of the big projects that is really being built, it's not, the slab is not one piece, or it's not, the load is not uniform. Every part of the slab is taking different load, but we simplify things here. So I just want you to understand the concept, how to use the software. we keep doing everything that is done, we are not gonna finish. So yeah, but any loads you have to account for. All right, so I have did a live and that's enough to practice in this class. So I'm gonna say okay. All right, so I have the loads are defined. So you guys tell me what is next. I define material, sections, loads. So I'm ready to draw the system, right? Okay, so what do you guys want to start with? Do you want to start drawing the columns? Slab? I'm gonna start with the columns. I'll tell you why. Because the thing is, I want to see, because I know I can't see it on my computer, like I can see your move each other. If I put this slab, I'm not gonna be able to see the position of each grid, so I can't draw the columns. Drawing the columns here is really like, if you guys remember last time, we have points, and these points has hinges, and we extruded hinges to be columns, right? Here is much easier. I'm gonna close this 3D view so that you guys can see the grids. Let me zoom in. Can you guys see the grids now? Okay, how about no? How about we display options, and I'm gonna see background or graphics and colors display. And let's make the background black background. So okay. How about that? It's all black.
You can see them.
All right. Okay. So for the columns, I'm gonna draw like look here. This is the drawing. You can draw frames using these, and you can draw slab using these, and you can draw walls using these. Columns is this one. So columns, like if I click on this, so once I click, if you guys remember in SAP 2000, there is a box gonna open here. It's gonna ask you what is the section of the column. This box is here. So basically, it's gonna ask you what columns that you wanna pick. I'm gonna pick the column, the 50 centimeter column that I did from before. So I'm gonna click on this and I'm gonna go all the way down to the C5050. All right, right now this column is activated. So I know that I have this column here. Look what happened here. It catched the grid. Once I click here, it put a column. It catched the grid here, and I put another column here. And I believe there was a one here. Oh, this one was shifted a little bit. And there's one here. And okay, I draw one of them is wrong. Okay, I'm gonna come back to it. And I have one here. Actually, I drew all this one wrong too. All right, let's see what I did wrong. All these are not right. So I'm gonna delete them. And I have this one not in the right position. So I'm gonna get back here. This is called quick draw column. So I'm gonna draw the one that I messed up here. And I believe these all the columns that were 50-50. So if you want to draw the corner ones, I'm gonna make them different, 25 by 80 centimeter. So I'm gonna put this one here. And this one here. And the thing is, right now, it doesn't show the column as a point. It shows the column as a cross section. So let's actually see how this look like in the 3D. You see? It's not only draw a point, it draw a column from this one and extruded to the next floor and also put a boundary division. So it did everything to you. So you don't have to select, assign, join, restrain, add hinge. It did everything for you here. And if you want to see this as a 3D, there is something here, it's called extruded view. So once you click on the extruded view, it's going to show you how's the cross sections look like. All right. Okay, so this is the columns. Let's get back to the 2D view. So if you want to switch between 3D and 2D, that's 3D and that's a plan. And when you click on plan, it's going to ask you which one that you want to see. I want to see story number 1. That's the only thing that I have for now. Okay, I'm done with the columns. If you want to draw walls, so there's multiple ways. I would make this one because I want to draw a column from a start point to an end point. So I'm gonna click on this, and when I click on this, a property object screen is gonna open here. I'm gonna say I want a wall 30 centimeter, and then I'm gonna draw the wall from here to here. So it's gonna draw the wall. If you wanna skip while being in the same drawing command, do right click. If you click skip, it's gonna skip the whole order. So you have to do it again. So I did a right command. And then I'm gonna draw another one here and another one here.
How do you change the,
Hmm.
big,
From what?
big,
I'm gonna show you. The thing is, I forgot a grid here. So let me add a modify grid, modify, and I forgot one in the Y direction at 2.75. So I'm gonna add 2.75 here, and hopefully it's gonna reorder them. And I'm gonna say, okay, okay. All right, so here's the grid, and I'm gonna get back to wall drawings. And by the way, there's something that I forgot to tell you. When we draw a wall, there's two options that you can draw a wall with. There's something called beer and something called spandrel. And if you guys remember, I don't know what happened to this screen. Yeah. Can you turn on the light just 2 minutes? So you guys remember when I talked about coupling beams? When you have two walls like this, and sometimes we connect the walls with something called a spandrel or coupling beam. The coupling beam, I told you, it has a special reinforcement. And the thing is, if you model this beam as a frame, the walls are not gonna feel that they are connected. But here, if you connect them with a shell, it's gonna be connected on this whole area. So the thing is, if you have a coupling beam that is really, really stiff, that is connecting shear walls, we usually draw it with a command that's called spandrel. It's a wall, it's the same section of the wall, but the wall is gonna consider it as having a wall section, but acting as a beam. So it's kind of like you are drawing one wall that has opening. Something like this. So it's kind of like a one wall that has opening. So we do this, you draw the wall with the option is called beer, and you draw the beam with an option called spandrel. So if you come here, you're gonna find out that there's two options, beer and spandrel. Since this is a wall, I'm gonna keep it as a wall 30 centimeter. Okay, and I'm gonna draw the spandrel for you now, but let's actually finish the walls first. So I'm gonna draw one from here to here. And if you guys remember, I have a core here. So I have core like this. And I have another wall in the middle since we have two elevators for this building. All right, so this is the walls. If you want to shift and draw the coupling beam for this core, and also I want you to look at the 3D now. So this is how it's look like. And if you want to shift to the plan of story one, I can come back here and let's see how the spandrel is gonna look like. Spandrel, and I'm gonna use the same section of the wall. Once I hit a spandrel, it's gonna ask me, what is the depth of this spandrel? Okay, it asks you, is this depth above or below? Like, do you want this to be above the story or below the story? It's usually below the story. So if you have the spandrel like this, nobody's gonna get in the elevator, so it needs to be like that. So I'm gonna put the spandrel depths, let's say, for example, 0.7. So I'm gonna say it's depth blue 0.7. And let's just start drawing this spandrel. So I'm gonna come here and draw this spandrel all the way here. So let's look how this is looking the 3D. Can you see how's the beam look like? It is the same section of the wall, but it is a shell element. This is provide more stiffness to the building. All right. So right now I draw columns, I draw walls. If you want to draw the beam, it's very easy now. Like I can come back to the plan and I can big frame. And when I big frame, I can bake the beam that I defined earlier, which is beam 25. So I can start by this point here. All right. So this is our beam. And then the thing is, all right, let's go to the slab. So right now I can draw the slab. So I'm gonna pick here slab 30 centimeter. And I'm gonna start with this point until I come to this point. So this made a slab in the whole plan. I want to avoid these two areas. You can actually switch it from a slab to something's called opening. So you can come here and pick the area that has opening, and you will act like you are gonna draw a slab. And then it is gonna open the slab. Oh, Control Z. You have to keep dragging down.
Does it open the wall as well in this case, or just slab?
I think you can open the walls, but I'm not sure, like if you draw a wall, if there's an opening in the wall, but we need to double check. All right, so here I have the system. You're asking me if I want to change to fixed. So I can go to plan and I can go to the base, and you are going to find your hinges here. You can select all your hinges the same way that we used to do in SAP 2000, assign, joint, restrain, and do fixation, and your building is now all fixed. You go to the 3D and you will find that this is a fixation. All right, so I have my geometry is done. So now I can actually pick all the structure and assign shell load, but I'm afraid it's gonna put the load on the wall. So what I'm gonna do, I'm gonna go to the plan, because wall is shell too. So I'm gonna select this slab, assign shell load, and I'm gonna say uniform load, and I'm gonna assign, for example, I'm gonna put flooring load of 0.15 ton, and it's in the gravity direction. If you want to change direction, you can change it, and I'm gonna hit apply. And I'm gonna click on live load. I'm gonna put live load of 0.2. I'm gonna hit apply, and then okay. If you want to make sure it says no selected objects. Okay, I'm gonna select the object here, and then I'm gonna hit apply. So if you want to make sure that the loads that you put are already there, you can right click on the slab, and then you are gonna find something called load assignments. You are gonna find that this slab has 0.15 dead and 0.2, and this is on top of the self weight. So also you are gonna find assignment of the sections. This slab has 30 centimeter section. So right now, this slab is ready for analysis, but we only missed one thing. What is it? Can I hit run now?
The mesh.
The mesh, right? Let's say I'm not gonna do a mesh here. We will see what is this software is gonna do. This software has a self-meshing. And actually SAP 2002 has a self-meshing too, but the thing is this is much more powerful. So we usually use the self-meshing option, the automatic self-meshing. And the thing is this software, it asks you what is the mesh size that you want to run your analysis with. If you go to analysis, you check automatic mesh settings, And basically this software has an automatic mesh size of 1.25. If you want to decrease it to 0.5 meter, you can decrease it like this, and then you're gonna hit run the analysis. Let's save this. Save. All right. Yes.
Honestly, I did a homework, and I just like did a comparison of like while you were teaching us, but like what the purpose of the mesh? Like, when
We talked about it. Actually, it's running then now. So, okay. Can you turn on the light? Okay. So, like we talked about it that all softwares are using finite element. Any software finite element, if it answers, if you heard about answers, it's used for research. We have to divide this into small elements so that we can increase the accuracy. Because finite elements only do the analysis at the joints. If you don't have any joints, your accuracy is almost garbage. But if you, the more mesh that you divide, the more the accuracy, because the thing is, it's gonna calculate here and it's gonna average in between. Here and here is gonna average in between. If your mesh is big and you have this, so it's gonna base on the average between these 2 points. So try actually to run your analysis with a mesh 2 meter and a mesh 0.5 meter and a mesh 0.1 meter and see the difference. At some point, you will not find that there's a big difference after 0.5. However, if you make it very, very small, it might the accuracy get really high, but the computational cost is going to be more. But like, this is where you are going to balance. Is that really worth it? Like, is that like I have to wait 3 or 5 days to get results rather than getting a result in 1 hour or 30 minutes? And to getting like, rather than getting a bending moment of, for example, 2.56, I would get a bending moment that is the accuracy at the after 6 numbers. So it doesn't matter that much. Okay, so let's see how the analysis results look like. So, okay, the thing is, I didn't like what happened in the mesh here, but to be honest, it's valid. Like, it can work. But if you want your mesh to be uniform, before running the analysis, I believe in the automatic mesh option. Okay, let's unlock the model. And let's analyze.
what's the one about?
Approximate mesh size. I'm gonna make it.
For walls.
Oh, okay. Let's actually, we have to do for both. Okay, we forgot analyze. Okay, automatic mesh settings for floors. It's 0.5. Oh yeah, I said I want a general mesh. I have to say I want a rectangular mesh. General mesh is fine and everything, but rectangular mesh is the one of the most accurate ones. So I'm gonna say, okay, this is 0.5, and the same thing in the walls. I'm also want to make them 0.5. Gonna hit OK. Run the analysis again.
Did it tell you if it's fading as well?
If it's what?
Slab fails.
What do you mean by fails?
Maybe
The fail is
load is way too high in the span of
the only way to know it's failing or not, you have to do design. And once the thing is, this is a structure analysis. So for example, it's gonna give you the deflection, for example, in the C is 0.001. It's 0.001. It's gonna make this slab failing or not. That's you have to check in code. So you have by either by yourself or either by the app. If you try to design by ETABs 2000 and hit the design button, it's gonna tell you if this is not failing. It's gonna tell you, is it like satisfying the design standards or not? So that doesn't mean if it's not satisfying, it's gonna fail. It just doesn't meet the standards. Same thing with reinforcement. You are gonna assume a specific amount of reinforcement and it's gonna tell you, oh, you need more reinforcement here. All right, so so this is how it is. Like it's the mesh actually looks great. If you want to show deformed shape, So you can come here and show deformate shape due to dead load or live load. And actually you can do contour lines. And if I want to show the contour lines in the Z direction, I'm going to hit apply, okay? So this is how the deflection look like. If you want to define load combination, you can define load combinations here, add combination. Maybe I'm gonna add 1.4 dead. I'm gonna add 1.6 live load, and I'm gonna hit OK. Okay, if you want to change the deformate shape from load case to load combination, so you come to combination and then pick the combination that you want. And here you can find the new deformation. All right, so that's for the deformation. If you want to show reactions, you come here, display support reactions, and you pick either load case or load combination. Reactions, we want to see FZ. If you want to FY and FX, you can show them as well. And since we have fixation, so definitely we have moments. So here is going to show you everything, the moments and everything. If you want to show them one by one, which I think it's better in this case, so maybe I will only show the reactions here. If you want to increase the font size, you can come to options, graphic colors, or graphic preferences. I'm going to increase the font size to 14 and make this to 5, the minimum, so that the numbers can increase a little bit. Yeah, so this is the reactions. If you want to show bending moment on the frame sections, so I'm going to show you to load combination. I want to show M33. Here has really good advantage. You can see in the 3D how's the bending moment look like. And also if you are in the plan, you can see the bending moment. That wasn't in SAP 2000. Like in the plan, you cannot see the bending moment. Here you can see the bending moment. And at any point, you can visualize the bending moment. It doesn't show good in the black background, but if we change it to white background, can you see the numbers? Yeah. So here's the bending moment. If you want to see the bending moment on the slab, so you can find M11 and I can hit apply. Okay, you can find the bending moment in M11. You can actually try this and try SAP 2000 and see what is the difference between the results. Okay, so this is for one story. If you want to make this a story, this one story building to 10 story, I will have to unlock the model. That's number one. And I have to prepare grids for the 10 story. So I have to right click, add and modify grid. I only have one story. There's something here, it says quick add a story. So I can add 2, 3, 4, 5, 6, 7, 8, 9, 10. So I can go to modify. And this is actually one of the most powerful things about the stories and ETABs. And this makes it really powerful tool for tall buildings. Why? Here you can define everything about the stories. Like you can make the story heights different. Like you can make one story 4, another story is 5. Let's say that, oh my God, I made the first story 3 meter and it's supposed to be 6 meter. If you change the story 1 to 6, it's gonna extend everything to 6. Extend the column, extend the slab, extend everything. And also, one of the most powerful thing about this that you can make master stories. Let's say that we have 100-story building and you have one story and another 5 stories similar to this story. But after that, there is different one, and there's 10 stories similar to this one, and there's another 6 stories similar to the other one. So you can define which one of these are a master story and which one of these are similar to each master story. For example, you can come here and say, okay, this story is a master story, but this one is not a master story. Once you say it's not master story, this tab is going to open, is going to ask you, this story is similar to which story? I'm going to say it's similar to story 1. And you can say this is no, no, no. And I'm gonna say here that all these are similar to story one. And I'm gonna say this is a master story, but these ones are not a master stories. And I'm gonna hit that all these stories are similar to story number 6. All right, so I had this, and I have, okay, yeah, let's pick this one is similar to story number 6. So the master stories, it cannot be similar to anyone. But the other non-master stories can be similar to the master stories. All right, let's say okay and okay. How this is helping us? Let's say, for example, you forgot to put a load on one of the stories. Like, let's say story one, that is master story, you forgot to put live load. In this case, when you assign load, you can say ETABs to ETABs. Put a load on story one and all the stories similar to story one. So basically, it's going to change everything in the master story. And this is very helpful. Sometimes you forget a beam, or you want to add beam to a master story, or you design something and you find it's failing. So you have to change something in a story. So you want this to happen to all similar stories. This is really big issues when you have a huge number of stories, which makes ETABS 2000 really powerful tool. How this is going to happen? Look here. There's an option here, it's called one story. And if you click on it, it's gonna have multiple options. It's called all stories, similar stories. What does that mean? If you are on the option of one story, so anything that is gonna change to this story is not gonna change to other stories, even if it's a similar. If you want the changes that is gonna make to this story to be changed to the similar stories, you have to check similar stories. If you want to do something that is already in all the stories, similar and not similar, you hit all stories. Like, let's say you forgot to draw a column. And this column is coming from a story number 1, story number 6. It doesn't matter if it's similar or not similar. So once you draw this column in a story number 1 and you set all the stories, it's gonna draw the column for all the stories. If you have a similar stories, let's say you draw a beam and a story, and you want to change this in all similar stories, you hit similar stories. So this is really, really powerful. I never felt how powerful it is until you deal with really, really big building. You guys remember when I said there's multiple loads and multiple pieces? This rule is really powerful when you want to add more loads or change pieces of loads and all these things. Okay. So that's for the stories. Let's go to the 3D. So right now I have all the grids ready. So all what I have to do, I have to select this story and replicate it in the 10 grids. So select to do this, I have to adjust the view a little bit so I can help me with the selection. I'm gonna say set 3D view. I'm gonna say XZ. I'm gonna make the aperture angle 0.
You don't want to select the.
Yeah, I don't want to select the hinges. Yeah. So here I selected everything. And right now I can edit and I can go to replicate. And in replicate, there's multiple options. There is something called linear, radial, mirror. I want to do a story replication. In a story replication, you are going to tell ETABS, where do you want this story to be replicated? I want to replicate this story from a story 1 to story 10. So basically, I choose 1 and shift and choose all of them. So basically, it's going to replicate this whole story in all 10 stories. But I don't want to delete the original. Because the original is still in the base. I want to keep it. Okay, so let's say okay. And then our 10-story building is here. So, and if you want to see extruded view, you click on this button, and then you are going to find the 10-story building. This building is ready for 3D lateral load analysis, and this is the only need for 3D model is to do lateral load analysis. Yes.
How do you do that command with the, when it's in 3D, like you don't have to click the rotation.
How do I do the rotation? Rotation, basically with the scroll here, if you click on the scroll and you keep moving, it's gonna make it like this. But if you have shift while scrolling, it's gonna do rotation.
Do you use the replication to get the first story? I think the story was already there.
In the replication, I replicated only in story 1, 2. Oh, you are thinking that I have two stories in the same one. Okay, let's see.
Maybe it owns the
Okay, let's get to all right, if I deleted this and oh, it's only one, so it's not duplicate. So if I click on this, okay, if you want to make sure that there's no two elements, you choose this. If it's C, two shells, that means it's duplicate. All right. Okay. So I have this building. All right, and we have 10 minutes. I'm gonna show you how to do this building in 10 minutes. Again, we spent over an hour doing this building. Let's see how we can use AutoCAD import and import this building into ETABs in 10 minutes. Hopefully it will be. So I have here AutoCAD. So the thing is, if I imported this AutoCAD to ETABs right away without any modification, it's not gonna work. The only way that AutoCAD can see structural components, you have to prepare the AutoCAD file for structural components. So ETABs can see columns from AutoCAD file if you have a closed line around the column. Maybe it's gonna take more than 10 minutes because I explain a lot. So look at this. This column, ETABs can see it as a column if there's a lines that are connected. Like let's say if you draw a broken lines, like let's say you have your column is like this. And you click, it's not connected, it's just a broken lines. ETABs cannot see it. So how you can do it? You either join them or when you draw the column, you make a bully line. Bully line, the pulley line is like a connected line. Like, okay, let me connect this here. So if you click at all this and make join on AutoCAD, so basically once you click on this, it's gonna be one piece. All right, that's a pulley line or a connected line. So this is how ETABS is gonna see a column. So you have to have your columns not in a group, not in a block. It needs to be separately. Like sometimes we group the columns with the hatch. So it needs to be separately from the hatch. Okay, so this is how ETABS is gonna see columns. ETABS is gonna see walls, same thing like columns. You have to have a pulley line around the columns like this so it can see it. Like even the core, it needs to be the same thing. Like if I click on this, it's only one piece. It
Why does the hash has to be separated from the polygon?
because the thing is, if you brought that, the thing is, if they are both in a block, if you import it to ETABS, ETABS doesn't see blocks, only see separate layers. And actually, hatch is a block by itself because it's multiple lines. So actually, once we import this map, we're not gonna see the hatch on ETABS because it's a block. Beams, it's shown as lines. So draw a line in the center of the beam or in the edge of the beam so ETABS can see it. So here you'll find that I draw a blue line here. The blue line is for the slab actually. The beam. Okay, let's see. I made a layer, and this layer is called slab ETABS. So I made 4 layers. These 4 layers here, one of them is called beam ETABS, columns, and slab ETABS, and I believe I have one, it's called wall ETABS. Yeah, here. So, and I have them in a group, and not in a group, I mean like here in the map. This is the only 4 layers that I care about because I'm gonna convert the wall into structural wall and the beam in a structural beam. So every layer is gonna be converted into structural component. So once you have all this done, you go to save as, and you save it as a DXF, not DWG. So you go here and it changed the savings here to DXF. And I'm gonna save this as building 10-story version 2. And I'm gonna say okay. And I have to close this. Like I have to close this file. All right. So, and then let me start. Actually, let me save as this, save as. And I'm gonna call it version 2. And let's delete this whole structure. Okay. Why I did this? Because I don't want to define the material, define the sections, define everything. Okay. All right. So what are you gonna do? You are gonna go to file, and then you will in file, you are gonna have import, and import, you're gonna find something called import DXF or DWG file of architecture plan. So when you click on this, it's gonna ask you, where is this architecture plan? I'm gonna say, this is my architecture plan version 2, the one I just named. And it's gonna ask you the units of this drawing. I'm gonna tell him that the units are meter, and put this plan in a story number 1, and the scale factor, don't scale it, and okay. All right, let's go to story number 1. This is the story number 10. I'm gonna go to plan, story 1, apply, okay. Here's the architecture plan of the drawing. By the way, this is not a structural system. This is just a drawing gonna help me to generate the geometry. Yes.
So you import the grid lines as well?
No, it doesn't import the grid lines. Okay, but I believe it. You want to have a grid lines. I'm not sure if it has a grid lines, but I don't need the grid lines for now. Because I'm gonna draw them. All right, so let's actually convert this drawing into structural system. Can you see here the model explorer? You click in this plus and you click on plan view and you click on architectural layers, all the AutoCAD layers are gonna show up. Okay, so let's see how we can draw all the columns in the structure in one click. I know that the columns are in this red layer, columns. By the way, the hatch is not there. So all what you are gonna do, you are gonna right click on columns, and then you are going to say add column object. So in one click, you draw all the columns in your structure. And by the way, since you already defined C5050 before, it's going to assign the section C15050. If we didn't, if we start by new file, it's going to develop its own section. It's going to make a 50-50 section, but it's going to pick the default material and the default everything, which actually what we did exactly. We picked the default material, but it's going to name it F section 1, not C15050. But because you already found this section already defined, so he picked it right away. All right, we are done with the columns. Let's do the walls. So I'm going to come here and I'm going to go to wall ETABs. And I'm going to right click and I'm going to say add wall object. So it draw wall object for all the location of the wall. Except I don't know why it didn't draw the wall here. I tried to figure it out. I don't know. Maybe try to do it at home, make the polyline right, and see if this is gonna be, because it usually okay with me. Like I never had this issue, but actually it's very easy for me. I can go to plan 1, story 1, and I can draw the missing one here. And I can make sure that this wall is here and it's not opening. Actually, the walls has openings, and I'm gonna draw wall centimeter, and I'm gonna draw one from here to here. And I'm gonna go to 3D, and I have all the walls. If you wanna draw the beams only have one issue. I'm gonna go to beam ETABs. I'm gonna add beam object. So the beam object is already added. And actually it picked the beam that we already defined. If you didn't have a beam already defined, SAP 2000 make a beam section is called none, which is a dummy beam that doesn't have any stiffness. So you have to select all the none that the SAP 2000 defined and assign the new section. But we are fortunate here that we already have a beam already defined to pick from. So we assign this beam right away. Last one is the slab. So I'm gonna go to the slab ETABs, the layer. By the way, slab, you only make, okay, let's open this one. For the slab, you only make a rectangular area. Like, can you see here? I draw one big rectangle. That's actually all what in the slab ETABs. So coming to ETABs, I'm gonna assign add area object. All right, let's click on this and see what sections we have here. This slab is assigned a section wall 30 centimeter. If you want to change it, you go here to slab 30 centimeter and say, okay, now it's a slab. Right click, it's a slab section. For the walls, I'm gonna go, sorry, for the openings, I'm gonna go to the plan.
You define the span though as a beam.
Oh, it makes the span because I draw a beam line in this area. I made it as a beam. If I want to change it, I can change it to redraw it again. Okay, I can draw an opening now. So I can come to opening and then I can make this and another one here. So if you want to redraw this, I can delete this beam and I can come to walls and I can say it's spandrel and the cross section is not opening, it's wall. And then it's 0.7 and then I will come here and draw it like this and then I would come to the 3D and this is actually it's 10 minutes. It's 10:45. And then if you want to replicate it, you actually let's select all this and see if it's going to replicate the hinges. Edit, replicate, stories, and then I want to replicate this. I don't want to do the base. The base I already have it. Story 1. And I'm going to hit apply. All right, let's story 1 and 2. Yeah, we shouldn't pick story 1. But it didn't show that there's replication in the last one. Okay, I'm gonna hit replicate. And let me zoom in. There's no hinges in the stories. Oh, actually there is. Can you guys see it?
Yeah.
I can see it. So let's do Control Z.
It just.
No, I believe it's everywhere. I just looked at the top. So I'm gonna make this 0. Okay. Sorry. View, set 3D view, XZ. And then I'm gonna select this without the hinges. Edit, replicate, story 2, and then I'm gonna hit OK. And right now we have a 3D. All right, so this is how to do the whole thing on ETABs. I'm gonna send you the project today because it's gonna be a tube system and it's gonna be on ETAB, and I'm gonna show you a tube system, the structural system. I'm gonna explain what is the tube system is. But the thing is, I'm gonna give it to you so that you can know how does the plan look like, how many columns, how does the structure look like, and then next time we're gonna start, what is the lateral load resistance system? There's something called the frame tube, outrigger system, shear wall system, bundle the tube system. So we are gonna see what is the different systems is and what is our project is gonna be. All right. So is it difficult? Easy, similar like SAP 2000. I don't see it's that big difference, right? Okay, sounds great. So see you guys next time. All right, yeah. What's your name?
Like.
Yeah.
The hunger is still due today.
I can extend it if you.
Yeah, because Canvas was down. multiple
Okay, I
yesterday.
can extend it, yeah, a few days, all right?
Thank you.
Sounds good.
So when I'm doing the distribution load, it's giving the distribution load like that on the side. Like I did the point for 20 distribution load and so. I need the rules because I'm doing the,
This is a distribution load on all the beam?
no, like that. So I put the distance and everything, but it's not, I don't know what it's keep doing like that.
Okay, so the distribution load is not from here to here.
If
It's,
like this.
but the thing is you need to divide this at this point, like you need to make a grid at 2 and 4. So this is should be, there's something here at 2 and 4.
I think this is the two, I think I did this.
But there's, okay, look at the supports. I have hinge, one roller, 2, 3, and this is free. So there's something wrong with the distances. Where's, because see how many grids? 1, 2, 3, 4, and 5. I need 1, 2, 3, 4, 5, 6, 7, 8. I need 8 grids at each change.
When I did from the beginning, like how to
Yeah.
do.
Yeah, so the thing is, we need a grid at each hinge and at each concentrated load, at each intermediate hinge, or at each separate element that has different load.
Okay.
So you need to like read away, and once you have that piece and you assign the load, it's gonna be assigned at that piece.
Oh, okay, I got it. That's why it's giving me a hard time because I did the point loads. It's good, but this.
But the thing is, the setting of the. Like, for example, if I pick this element, and actually it's. I feel like you draw multiple elements on top of each other, and that's not right, like.
Oh, I think yes, I did like an element because I was trying to do it like that, but.
No, look at
No.
this here. This is one big element, and there's here an element. So there's multiple elements on top of each other. Like if I select here, I have 2 frames on top of each other, which is not gonna give you an accurate result.
So how can I delete like that?
Okay, like I don't know where's the delete here. You see? This one, you have to first draw the grids right. And once you draw them, you draw you draw them.
So I
left
do
onto
like,
one.
yes, in each side.
Yeah, like side one by one from grid to another.
Oh, okay. So then if I want to do the distribution load, it's gonna be like easier. Right, I think.
Yeah. Once you pick it and assign the distribution, I believe it's gonna be right.
And another question for the table and label here, I apply the and define, right? Like load
You
combination?
define the load. No, wait. I don't ask. Did I ask for load combination? No, I asked just to put the loads. Don't do
Just
it.
the- okay, great.
Yeah.
Thank you, Dr.
Alright. Yep. Oh, yeah, I'm gonna be my office right now. 3626, that's all.
Thank you. Yeah.
Okay, sounds great.
We're good? Good, good, good. We're good?
Yeah.
Very cool.
I just have a quick question.
I want to see something on your exam first before we start.
Yeah, go ahead.
Let's see, question 2. You got the force right. Let me check something here. Alright, this one is supposed to be 12. No. But you know what?
Could it be due to the rounding or?
I'm trying to. So you got here the theorem rate, you got horizontal force, right? Things you should do the general theory and get bending moment at each one of these points and apply the moment at each point is going to be minus h, which is 0.
Correct.
So the value is here, but I don't know exactly what you only take the 10. I don't know what are these values. That's y1 and what are these values. Since you did, I don't know, I can add maybe extra point. Since the big part is to find the horizontal force. Okay, let's figure if you have other questions.
I guess this one, if you want to even just
The thing is,
how what I did wrong
I know what you did here. I see here it says support, and you put I don't know, you increase the number of reactions or something. Like you put here, here, and yeah, you put the thing is there's no horizontal grids. Even if it's cylindrical, there's no horizontal. It's only one vertical reactions and 2 moments. Because
Okay.
this is grid system. Grid system doesn't have horizontal reactions.
Okay.
It have verticals and moments. So that's why that make you got that has 12.
No, it's okay. I'm not trying to.
No. If you
The one
get
was this one
points.
where when you said where I missed work, I think didn't have any numbers. This one might be wrong. I did put this in the back. I don't know if you checked that. Maybe it's wrong. So
Well, maybe I didn't see that. Okay, let's see.
because I had put here
Yeah,
the back, but
like here I didn't see
any values.
like I see that you put the 1. I don't know what was that for. Like the thing is, I did it in the class. You get the moment you did 6 ton separately from this. So yeah, this is the bending moment of this.
Correct.
So yeah, but suppose you put the value like W L 2. So W multiply 1 multiplied by 12
Okay.
and over 2.
Which was
It was
I
1
guess
kips, right?
these ones right here would be the.
This one, WL square over 2. This,
I don't know why.
but you cannot actually do superposition to them right now. We have to keep them separately and make a superposition of the final deformation.
Okay.
So yeah, I saw you did everything, but let's see here. So actually, wait, I think I have the. Oh, that's not. Did you check them on the answer?
No, actually, it didn't go. Didn't know you shared them with us.
Pictures. And plus here, leave the only issue that you have here, that you put them together. So, well, let me, since you already continued and did some foundation. So you got two. Spoons. If
it's wrong, it's wrong. Like I'm not
Yeah,
trying
well,
to.
I'm trying to see if you deserve any points, you know, so. One is, okay, R reaction at C, you got it right. So with, got it, ML over two, this one is supposed to be ML over six. Well, okay. So here you have 6 more points. Yeah. All right, so how about you take a picture
Okay.
and send it to me so I can update it in on campus,
Okay.
right?
Thank
Okay,
you.
so
I really appreciate it.
Yeah.
And I wasn't like trying to complain.
I
was
know.
more just.
You wanna know
like,
that.
like for example, this one, now I understand.
No, but I didn't see that back. You didn't sum them together, so, you know, like, you summed them together, you're supposed to do them separately, and then in
And
the
then put them
information,
together.
you can add them. All
Understand.
right, sounds
Thank you
great.
so much.
Sure.
Appreciate it. Have a good day, Professor.
Yeah, come in.
No, I did.
Oh. See. This. All right, did you check the model answer? No? Okay, the model answer is online. Let's see what you did. You. Together from this load and this load. Usually we find the deformation separately because the thing is the way that the sheets, the table in the appendix, it is designed for having the triangle individual. And actually that's why before the day before the exam, I had an example of a simple beam with a load in the middle and I separated them together and tried to show you.
Got you, yeah.
So I believe that is.
Yeah, that's why I got that answer.
Okay.
Oh, so I did not know that.
All right, so
Yeah.
let's see how did it go.
Yeah, for this one, I apply a moment at the end.
Yeah, well,
find it.
okay, you put 1K to find the displacement
And
and
then-
rotation to find the moment to find the rotation. And you got the shear and moment for both. Well, we suppose only to get the moment, so I'm only because we don't.
It's
We
just-
can find shear deformation. There's a rule for the shear deformation,
But I always
like
find it here to get the graph.
the L over the AR or something. That is there's a rule, you use this shear and this shear and try to find, it has a rule, but usually it's a small amount. Anyway, so you tried to get delta based on the moment of 44. Thing is, one of them is a pink and one of them is a white. So one of them is gonna be, I don't know, 1.1/3, and one of them is gonna be 1/4. So that is the only thing, but you know,
Yes.
maybe.
Now I know, yeah, that I have.
So let's go with it. 2 points, and I'm here. You did it right. Like this is the answer. So that's why I give you the question one. All right. So this is 9. Just send me a picture and on Canvas. Yeah. And then I'm gonna update your card.
Thank
Okay,
you.
sounds great.
Yeah, so now every time that I have to solve for this, I have to split the
To
forces
split
and
them.
then the results sum them up.
Yeah, you sum
Okay.
the theta and the deformation
Okay,
together.
okay, gotcha.
Yeah.
Okay, I did not know.
Because
that.
this is the way that the tables are
Oh,
designed.
for the table.
Yeah.
Okay, but if I do the whole
But
formula, it's
if you
that.
did a formula and you integrate it, you can do it
Oh,
that
okay,
way.
okay, yes, because I was so used to do the formula, because
Mhm.
every time.
It's gonna be huge. It's
Yeah,
gonna
yeah,
be
I
a
know
lot.
it's huge.
Yeah.
Yeah, but I've done it like so many times, because I used to practice a lot in mechanics and materials.
Oh,
and
really?
Yeah, because I really like it. The only thing that.
You had your degree from here? FIU?
Yeah, I graduated this semester
Mm.
from bachelor.
Who's Dr. Song is the one teach mechanics of materials, or
No, it's Cora.
Cora
Mechanics
teach
of- yeah.
mechanics of
Yeah,
material? Oh,
mechanics. And I
okay.
really love that class.
Oh, nice.
Yeah, and then the class that I taught as structural analysis, I took it with Professor Lau.
Oh yeah,
And-
how was it? Was it
Oh,
good?
I love that class.
Oh, nice.
Yeah, yeah, yeah. A lot of people didn't like that class because it was kind of hard.
Structure
But I
analysis is
love-
the hardest of classes.
but I
Hardest of
love that.
classes in our engineering curriculum.
Mhm.
And by the way, all this is static loads. When
Yeah.
it's dynamics loads, it's like it's really completely
Yeah, I'm gonna
different
take
game.
that class next semester,
Yeah.
like the structural dynamics.
Usually anybody who's seismic designer, he usually he's supposed to have
Yeah.
dynamics in
Mhm.
background.
Yeah, and then I wanted to ask you, have you thought about, because last class I couldn't come, have you thought about like, what is this called? Like influence line?
No, we don't have influence line in this class. Are you taking your BE?
No, I'm taking the FE, but I like.
It has influence lines?
Yeah, like.
Well, I give the
Because I'm
others
really
I used to
confused.
teach it in Egypt. I have notes, but some of them are in Arabic,
Mhm.
some of them are in English. I'm not sure if it's gonna be helpful to you to take
Mhm.
pictures. Maybe you can see how's the influence lines look like.
Mhm.
I used to teach this class in Egypt, not here. But can you see so maybe if you wanna step outside so I can let the other student in, maybe you take one to translate. This is the steps to do it. Maybe you put it in Chat GPT.
Mhm.
How to do it. I put some examples, you know, maybe you see how's the examples look like. It can some of them are in English, you know. So yeah.
Yeah.
You wanna take a picture?
Take
Okay.
pictures and.
Okay, sounds great.
Yeah, thank you, Professor.
Please. Oh, how's it going? Good. What we got?
So, yeah, so. First one, I think. I guess really call for the support. I think that's where.
Yeah, yeah, that's actually was also not to be. So only you had two reactions. Yeah, even if it's cylindrical, grid system doesn't have horizontal forces. It has vertical and it has moments. So even if it's cylindrical, this is not even it's gonna be a moment. Like
Yeah.
it's gonna be this one is gonna be a moment that way. So it's something like this. This one can take horizontal reaction, and if it's cylindrical, like yeah, this is the cylindrical support, something like this.
Yeah.
It can resist the vertical
Yeah.
and can prevent the torsion, but actually can rotate that way. So it allows the bending moment that way, but not allow the bending moment that way. So if this is my slab,
Yeah.
my slab can bend that way, but cannot bend that way.
Yeah, okay.
Yeah.
Yeah.
So that's why we have
Yeah,
this.
I'll go clinical.
Yeah, but let's see. This one you got it right, except ISS 9. Yeah, you said
minus the reaction. So you should have here degrees of freedom minus the reaction. So this is 20, be 21 minus, where's the reactions? 11. So this is equals to 2. Yeah, so V10. Because the thing is, the degrees of freedom and the reactions where the support as there's no degrees of freedom. Like
Okay.
actually you draw them right. Like here, the degrees of freedom is 10.
Yeah. I
So
see that. That's the thing. So when I see the difference, I'm like, okay,
mm,
I know it's something wrong, but I just don't,
Mm.
I don't react that.
okay. Okay, that's your 2 points. So 20. So let's see.
So the second one had an idea, but as you pointed out, I think the reaction compression is
Yeah, you took a picture? Okay, thanks.
from an angle. So I think I didn't think of it that way. I just
The
thought
thing
that
is, where's the horizontal force?
horizontal force should
You
be-
got AY, yeah, you assume that the horizontal force is equal to the maximum compressive strength. So
Yeah.
this is the only issue. So the maximum compressive strength is the force. This is the compression in the member.
Yeah.
Okay. Horizontal, I didn't say that the maximum horizontal force is 85. I said that this is 85. So you got this 54. Basically, you can get what is the angle here. And then the component C, let's say which one is theta? Actually, I estimate that this is theta. So let's say this is C. So C sin theta is going to be equal to the 4. You know, C is 5 in theta. If you find theta, if you find this is going to be C sin theta. So you can find. So this is the only thing, and definitely if you got it right, you draw this right, like the bending moment, the everything, but the horizontal force.
Because I assume it.
Yeah, so everything here is right except this. So if you got this right and plug it here, which actually is the whole thing.
The biggest part.
Yeah, but you did great. I like your organization. Okay, so you those 3 points are
Yeah.
the horizontal force.
This one I blacked. I don't
This
know.
one-
Tired. Yeah, I was tiring her. I think I did this one last.
The thing is, you didn't do anything related to conjugate beam, like
Yeah.
here. I would convert this to fix. Okay, you
Yeah,
did
so
fix.
that's what I did. I converted the actual structure.
I'm supposed to be free.
Yeah. So I converted the actual structure to this, and then at that point, I was like, I don't know.
Okay.
I don't know.
You did this right. Let me choose. This is supposed to be because this is supposed to be in under the hinge,
Okay.
and this is supposed to be hinge. So that's for the conjugate beam.
Yeah, and then after that, I just
Then you were supposed to do the bending moment that comes from this. So this is not the bending moment
yeah.
that comes from this one. So I was trying to find a way to give you any, even if you draw the conjugate beam right.
Yeah, no, it's fine because this one I know I meant it was like I'm like banking here and it just went up like I was confused because I was like, okay, that's the deflected shape. Because I knew that deflected shape, but I just couldn't figure out why I couldn't go through
The deflected shape of this beam, it's supposed to be something like this. That's how it's.
yes.
Because the thing is, if you have a bending moment like this, and you're making the beam like this, so this is gonna go up and this is gonna bend down. So it's gonna be something.
This support.
I actually have, this is how it looks like. I uploaded the model answer up there. You see?
Okay, I got racing. Okay, so that support that's gonna push it up.
Yeah.
Yeah, that's why that one was.
All right, but I might, no, because I didn't see that. So maybe.
This one I knew I got the first.
You're-
I got the first part, but I didn't get to do the after. Probably do anything.
I think, okay, the only issue is that you superposition the loads or the bending moment. I wanna rescale them. So I have here, okay, 6. All right, well, you put 1. Okay, here's the thing. This 144 is coming from the W, which is WL square over, which is 1 multiplied by 144 over 2 and 6 multiplied by 12. So you found that the summation is 34. And then you start doing the whole thing in that. Which the way that this is designed, or the table's design,
Okay.
it's not only a parabolic, this comes from this load, the moment is a triangle. 6 multiplied by 12 is gonna be 70. And then you have the parabola coming from the distributed load. Something like this, which is WL square over 2, 1 multiplied by 12 square over 2 is gonna be 100. All right. So the thing is, you have to find it that comes from this, that comes from this, and then separate.
Okay.
Because the thing is, the way the table's designed is not designed to merge these two together. It's a triangle and parabola. This one,
The factor, I don't know, 1/3, and this one has 1/4.
so
So I only used the 1/3. And
use the 1/3 for
The parabolic curve.
Okay, gotcha.
So
you have,
so that's why, but all the steps I believe are right. Like all your steps are right except the step. But okay, let's say you got 2 points here, 1 point here, 2 points here, and 2 points. So 2 plus 2, 4, 5, 7. Right?
That's fine. So for the homework, are you gonna extend it?
I can extend it.
Because I'm trying to do it yesterday, but obviously.
No worries.
obviously
Yeah, I'm
Amazon
gonna
and
I'm gonna
all that.
extend by the end of this week or something.
Yeah.
Okay?
Perfect.
All right.
So the project's gonna be groups or is it gonna be?
Yeah.
Okay.
All right.
Yeah,
I'm gonna
alright.
tell you guys next Thursday. You will.
Okay.
No worry.
Thank you, sir.
Yeah, absolutely. Have a good day.
Yeah. You're always here. This is your office.
Yeah, that's my office. Tuesday and Thursday.
Okay, okay, right.
Sure. Right, come on in. Good, how are you?
Good. I have a quick question.
Yeah.
For,
The exam?
oh, no,
No, are you sure?
yeah, I'm honestly surprised I got that grade.
Maybe you will, everyone walks to his point. Maybe you will get more points.
Oh, I
But if
didn't
you want to
bring,
discuss, okay, if you want, we can. Yeah, sure.
yeah, because I blanked in the second half and I don't know. I just didn't think I did as well as I thought I could.
All right, yeah, sure. If you want to discuss any of the questions,
So,
yeah,
I was gonna ask for number 2.
it's the frame.
Yeah, for the frame.
The formation looks okay, but
Yeah.
yeah, do you have?
'Cause I know for the frame, sometimes don't you split them like intermediate hinges, like around like the points? Or no?
it was there was intermediate hinge here, right?
Yeah,
So did you model it or no?
no, this is without it modeling like that.
So where's the bending moment? So if the bending moment shows like this, that means you didn't release the moment.
Mhm.
So you have to do the intermediate hinge.
Okay.
Do you know how to do it?
It's the release partial
Yeah.
density, right?
So basically you're gonna select this frame alone
Mhm.
and you release one end. You
Mhm.
don't release the other end, but because the other end is frame, doesn't have intermediate hinge.
Okay.
So you release the second end because this is the start and this is the end. Depends on how did you draw the frame. If you draw it from here to here, so this is the second point.
Oh, okay.
All right. And this frame, this is the first point. So you release the first point and you leave the second point.
Oh, okay.
All right. So this is gonna be the moment left and the right.
Oh, okay.
All right.
What about here at these points? I think they're
If there's an
also-
intermediate hinge, you have to select this frame and release left and right. This is called link member because it's kind of like grabbing the frame from opening. So we usually put a link member with a release at the start and the end.
Oh, okay. And for this one, we should model it as just like one like part, right? Because like I know there's like the grid spacing, so I had put them as like 2.
So for this one, I would do grade 1 and 2 and 3. I put this grid so I can draw this point. Yeah, I believe this is the minimum diagram. And yes.
Cool.
All right, sounds
And-
great.
Last question for the grid spacing. I know they put like the numbers, like the 1, 2, and 3, like to reference them. How would you like take that out? So like it doesn't show.
I
like, when
think you
it's
need to
shown.
play in the graphics. Do you remember when there's options and there's graphics?
Display.
No, I think in options.
Mm-hmm.
Because display is to display loads, load patterns, doesn't play in the options of the software. You go to options and then you will find something that plays with the graphic.
Mm-hmm.
So that's where you go. Right?
Thank you.
Okay, sounds great.
Have a nice day.
Is there any other students outside?
Oh, just one more.
Okay, just send them in. All right, thanks. Hi. What is your name?
Ronaldo.
Ronaldo?
Yeah,
Where are you from?
Dominican Republic.
Oh,
So I
nice.
remember,
You got your degree from here or from?
no, from Dominican Republic.
Oh,
Yeah.
nice. So you just came here for your master's?
Yeah, no, I've been working in Naples for a year now.
So when did you come here? To the US?
To the US? Yeah, like
Long time ago?
no, in June,
In
June
June?
last year.
Mm.
Yeah,
So you got your bachelor from
got my
what
bachelor-
university?
it's called Pucamaima. It's
Mm.
Pontifex University Mother and Magister, I think it's called in Santiago,
Nice.
where I'm from.
Is it like 4 or 5 year degree?
It was 4 years.
Mm.
Yeah, they like changed the curriculum so that it will just be 4 years. But I worked there in structural.
When did you graduate? You got your bachelor?
21.
21.
Yeah.
And then you came here like
No, not straight away. I worked there
for-
1 year in construction, then 2 years in structural design with my previous boss because he was independent in the Dominican Republic. He studied here in Virginia, then moved back.
So you moved with him?
No,
Oh.
no. That's the reason why I moved because he moved to Canada with his family. So because it was only the two of us, I was like, well, I lost my job, so because I'm a U.S. citizen, I was like, might as well go
Oh,
to my
nice.
family in Tampa and try and make it work. And
Nice.
it worked so far.
So you came to work here first,
Yeah,
but you worked as an engineer?
yeah. Because when I came here, I did all the paperwork with the NCES.
Oh, so you were
And
able to
and I studied for like 2 months and got the FE. I
nice.
passed the FE, then got a job here in Naples and continue working.
So you are still working in Naples?
Yeah. I work on Naples and then just come here because I have some family that lives like 3 minutes away. So I'm
So
staying
what
with
makes
them.
you decide to go to your master's?
The different things
Like you want to just improve your background, or you
yeah.
like academia, or
pretty much because I want to get the PE2. I want to get it sooner because the problem is that those 2 years of experience, I learned a lot how to, especially in the Dominican Republic, we have a lot of seismic design. So I learned a lot from my boss. He was really good. He was one of the best engineers. He
That's
was
really
really
great.
young too.
Yeah, I like your background. You have really, really strong background.
Yeah,
That's-
I learned everything in ETABs, how to design for seismic.
Oh,
I
so
mean,
you already have ETABS background.
yeah, I do.
That's why you do
Almost
probably.
yeah, almost 2 years.
So what I said, it was like you know everything that I
Yeah, I was
use,
just cruising through it.
even the AutoCAD part, the import part.
No,
of
no,
the
that
architecture?
I haven't done.
Okay,
I've
at
never
least you
done
heard
that.
something new.
Yeah, but I work mostly on Revit now.
Revit?
Yeah.
Yeah. I have done a lot of stuff in Revit. Have you tried Robot?
I tried.
Yeah, because I
But
did
it's-
some stuff on Robot too. Because
Yeah, I don't know. I've tried a couple of
but
times.
Revit is much better. Robot is
Yeah.
it's too much and it take like a lot of
Yeah.
stuff.
Yeah, but because Robot is like ETABs from Autodesk.
Yeah, exactly. But Robot is more difficult than ETABS.
Yeah.
ETABS is much easier.
I've
Yeah.
tried a couple of
Yeah.
times to make it work, but I have
But
never
that's
been
good that
able
you
to.
have. But do you do advanced stuff in Revit? Do you do dynamos and all these?
No,
or no?
no, yeah.
Just
The
normal
most
stuff?
I did, in my opinion, was like the detail
Like families?
steel. Yeah, and the steel
Mm.
connectors, like
Mm.
the details one, because we mostly work on steel.
Mm.
I mean, we did concrete too, not timber, because we don't use that in Dominican Republic.
Mm.
But like
I believe Dominican Republic is kind of like Egypt. You guys have everything reinforced concrete, right?
yeah, and
Yeah. We don't have
masonry.
timber. And
No,
we have
not at
metal,
all,
yeah.
not at all. Masonry
Did
and
you take a timber class here or a
I
metal?
want to take it.
Mm.
In my job, I've been learning a lot
Mhm.
from timber design because of it, because I have
Mm.
absolutely no background in timber. But yeah, so that's pretty much the thing, is that those years of experience I cannot count it for the PE, and I want to
Mhm.
get my PE.
You cannot count the one in Dominican
No,
Republic?
because it counts the years of experience underneath another person with a PE.
Mm.
So also because the master counts as 12 if you do it like not full time. So it's like, oh, I can get the masters, get a better background, and at the same time get my PE faster. So
Who's your advisor?
I don't have an advisor yet.
No?
Yeah, that's why I'm
Oh,
here.
okay.
Because yeah, I have
Oh, yeah,
the
you talked to me early in the
Yeah,
semester,
yeah.
yeah.
So I downloaded the form.
Oh.
He told me that I have to meet the other one. So I have a schedule already, one with I think it was Linfei.
Mhm.
I have him scheduled for tomorrow.
For what?
Yeah, for this meeting too.
Well,
So that he
I'll
can
tell-
explain the courses
I
he has.
think, oh yeah, I think this is you only pick one advisor. You don't have to get signature from everyone, do you?
I don't know.
Maybe you ask Diana, the
Uh-huh.
program coordinator. Do you know her?
No.
Maybe you ask her, because the thing is, I believe you only, this is all the faculty in the department,
Yeah.
environmental. So you only get the signature from one faculty that is going to be your advisor.
Oh,
So-
here it says
Mhm.
to become acquaintance with faculty members in your area of specialty and choose from your academic advisor. You are asked to meet with all professors in your areas. So
Uh-huh.
you will learn about, yeah, and it says like what they teach, the courses and all that. Yeah, so,
Each faculty? Uh,
I mean,
but I'm not sure if they will, okay.
yeah, if
well,
they will require.
So we sign here just to make sure that you meet with us?
I
or-
think so. Yeah,
Okay.
that's the purpose of it.
So today is 10/21.
Like, as I told you, I would probably prefer if you were my advisors.
Yeah, yeah,
I mean,
absolutely.
but I'm still prefer
Yeah,
if
yeah.
I meet at
Sure.
least every single one that I can, because
Yeah, well,
I didn't get my bachelor's here, so I don't know most of
I
the
understand, yeah.
professors. So I'd rather meet them.
So you are taking like 2 years to get your master's, right? Or
I'm hoping to be at least 2 years, yeah.
what classes are you taking this?
On this semester, this is my first semester, only this one and wind engineering.
When
right
engineering
now.
with
Yeah.
Giannis?
Mhm.
It's online, right?
Yeah, that one's online.
Mm.
I'm hoping to take all the other designs, and because
Okay.
I know you do the
I teach
HAT
risk,
one, right?
risk and
Risk,
reliability.
Uh-huh.
Do you have any programming background or no?
Programming? Nah.
Hmm.
I did a little bit in my bachelor, like one course of
Mm.
programming. I think we did some Python,
Hmm.
but no, we didn't go to
Okay, so this course, it needs a little bit background in programming, but
Mhm.
not much, because I explain every element of my programming. Like if I have for loop, while loop, I say everything. I'm not gonna like let you, I explain all the codes, but
Mhm.
if you have a little bit of background,
Yeah.
it can help you. I
Okay.
believe this course it's really not an easy class. It has a lot of coding, a lot of GIS analysis, but you are gonna learn a lot of stuff, new stuff.
Mhm.
It can help you if you want to be a forensic engineer, if you
Mm.
want to be a risk modeler.
Mhm.
So
But that can also help, just like even the structural designers, in specifically if you work like in this area with all the
well, it can help you how to think about that hazards are not deterministic and
Mhm.
even loads are not deterministic,
Mhm.
and that's actually the nature of everything.
Yeah.
We have been doing structure analysis for 6 ton on the beam, but there's nothing such thing as 6 ton or 2 ton.
Mhm.
It's always a mean and a standard deviation.
Yeah.
So that's why I have to start with the statistics and probabilities, and everything is going to be probabilistic. The loads on the beam, the reactions are going to be probabilistic.
Mhm.
So yeah, it's gonna take you all the way to we are gonna do interesting stuff, but I don't want to like because students might think it's easy or something, so I should say up front it's really difficult.
Mhm.
But you are a good student. I don't think that you would have any problem with it unless you put the work and effort. And
Yeah.
I believe any student, but there's some students they are not open to new things.
Mhm.
I'm not sure. I didn't take risk and reliability in my country. We don't have this
Mhm.
knowledge, I believe, there, but here it's really, really important class.
Okay.
So yeah, maybe if you want, yeah.
I will talk to, because I didn't find the form for like to select the advisor. I didn't find that one, but should I speak with the Diana?
Diana, yeah, maybe.
She's here?
Yeah, I believe or if you go all the way down, she is the one the office in the front.
Okay.
Yeah.
Okay, I'll
Close to that
ask
show.
her then.
Okay,
Yep,
sounds great.
Thank you very much.
All right, thanks. Have a good day.
Yeah, you too. No, I'm gonna go speak with Diana, so.
Aprovecho que estaba preguntándole hacía así, y él me dijo de que aparentemente uno sí puede coger clases de timber o de masonry, pero tú tienes que, I mean, there's like a way that you can talk with people from FIU, so they can like transfer you to UM and take some classes. So averigua, algo raro.
Hello.
It's gonna be like really quick.
Mm.
I'm really invested like into ETABs and stuff, as
Mm.
you can tell. Do you have like any drawing that I can just like practice more and
I did the one. Do you remember there's one adverse I uploaded on Canvas? It's called all class work. They will find multiple
okay,
plans. You can actually do them. And I believe there's videos on my YouTube channels doing them. So
Yeah.
if you want to follow up.
okay, cool.
All right.
Yeah, and so you were mentioning something about shells. I know that shells are usually like the ones that we use to draw areas like slabs
Mhm.
or
The shell
shear walls.
element.
Yeah, the shell element.
Not the shell structural system.
Yeah.
Yeah.
And also that has 24 degrees of
Yeah.
freedom, right?
Mm-hmm.
So it has
6
one,
of each joint.
yeah, and also they has like the rotational. No,
3 translation and 3 rotation at each joint.
okay. So we usually pick that because it basically represent better at the moment of like having to use like to see the deformed shape of the structure.
Well, we use it because the thing is sometimes we are sure that this slab is not gonna twist or something, so we can make it blade. But the thing is, what if this slab twists that way, has torsion?
Mhm.
So that the only thing to capture this is the shell element.
Okay.
So, but mostly the slab have the loads going down, so you have bending that way or bending that way. So that's 2 bending moments. For the walls, it's something like this, so you know that the bending moments are that way.
Mhm.
So walls are something different from the slab, but we usually, okay, I'm gonna big shell, so I don't worry, is it wall or is it slab? So shell is gonna do both.
Okay.
So shell is like the right option for both of them.
Okay.
However, shell and plate work for slab, shell and membrane work for walls. But sometimes you have the wall, all the bending moments are gonna be that way. So you have a bending moment like this way, that way, and this point in this way. So every point has a moment and 2 translation, X and 1. All right. But what if this wall is a retaining wall that has a soil behind it? You have the shear wall here, and this shear wall is at the soil with another structure. So this shear wall has a moment that way, which is not accounted for in the membrane. Membrane is only take moment that way.
Okay.
So the shear wall, once it has moment that way, so it's acting like a slab. So that's why it has to be a shell, not a membrane.
Okay.
So shell is kind of like take advantage that whatever happens to the shell, either getting load that is not calculated for, so shell is gonna do it for you.
Okay. And last question. I'm really invested as well on the structural analysis of the structures when they are like subjected to specifically to lateral loads like wind
Yeah.
and mainly seismic.
Okay.
In the art.
We're gonna have this in the class for the next couple lectures.
Okay. So in that case, I know that I heard that structural dynamics is like one of the most complicated classes,
Yeah, it is.
but I don't know. I'm still thinking. So
You wanna-
my advisor is Armin Arabi.
Mhm.
But I mean, now that I'm here, I just wanted to ask you, is it like really worth it to take structural dynamics? Or
Well, definitely structural dynamics is gonna help you, but structural dynamics is different from seismic design.
And if
So you are gonna learn dynamics, but you're not gonna learn seismic design because this is a structure analysis class, not a design class. So, but the thing is, you cannot take seismic designs without background in a structural dynamics. So
Okay.
structural dynamics is gonna help you to do seismic design. I don't think we have a seismic design here in this. But structural dynamics is going to be your first step. I'm going to teach a little bit of structural dynamics in the next 2 or 3 lectures.
Okay.
And mostly on the analysis side, not on the design side. Okay.
Okay.
So that can give you a little bit of background. What is the dynamics is all about and why we we need this structural dynamics.
Okay. Okay.
So, all right.
That was
Sounds
okay.
great. Thanks.
You want me to close the door?
No, leave it open.
Okay.
Another thing, Omar.
Yeah.
Diana's not here right now,
Ah.
so I'll just come another time.
Okay, maybe you email Dr. SJ Sangli
Okay.
because he's the undergrad. Oh, you're the grad. You have to email Chia Jen
Okay.
because she's the graduate program director. So you ask her exactly the details. She's gonna answer you.
Yeah, no problem.
All right.
And also, for the ETABs, should we request the trial also? Or
Yeah, I think
It's not included with the SAP one,
no, it's a different one. So you have
so
to
you have to request it again.
request the trial version.
No problem.
All right.
Thank
Okay,
you.
sounds good. Thanks. يا سلام.
انا شفتهم عند حضرتك بس قلت هاجي
بعد الميد ترم بقى.
سهلاوي طويلة.
كله بيلحق الدرجة بتاعته.
اه
عامل ايه؟
تمام الحمد لله تمام. تمام الحمد لله. انا البتاعة دي اتقبلت، اللي هم الاثنين
اه
ابستراكت.
امم انت
اه
قدمت اتنين؟
محمد دول،
طيب تمام.
واحدة في اللي هي بتاع الجزء بتاع الماشين ليرنينج، والتانية اللي هي
غالبا الديدلاين بتاع
الريجستريشن.
برضه قرب. احنا قدمنا اي ام اي صح؟
اي ام اي ده السنة اللي فاتت، لسه ما قدمناش السنة دي لا.
اه انا قدمت سيشن المفروض ان هم
متهيألي لسه.
اوكي ميني سيمبوزيوم ديدلاين اكستندد. اصل انا قدمت سيشن، هم لسه الابستراكت ما فتحش لان احنا هو اول حاجه انت بتقدم على سيشن، وبعد كده بعد ما السيشن بتتقبل بيقوموا هم يفتحوا الابستراكتس عشان تتحط جوه السيشن.
تمام تمام.
فالديدلاين بتاع السيشن كان في اكتوبر، وانا عملت بروبوز للسيشن مع نفس الناس اللي احنا um, is now accepting proposal from any symposium October 15. I don't know how it was extended but خلينا نستنى. هو بيقول لك نوفمبر فيرست هيفتحوا الابستراكت سبمشن. برضه خلي بالك من الديدلاين ده برضه عشان عايزين ايه ان سبميت فيه.
حاضر.
تمام.
تمام.
فممكن في الديدلاين ده انت تسبميت اللي هو الشغل الجديد بتاع الاي اي والشغل بتاع الفلد،
تمام.
اتنين ابستراكت. تمام. ده هيبقى في كولورادو. تروح كولورادو بقى اول مره بولدر. تمام. تمام. بس ده اللي ما اعتقد اللي عندي. ما اعرفش لو في مؤتمرات التانية. ما اعرفش انت بيبقى في حاجه اسمها تي ار بي وحاجات واي جي يو. وخد بالك بقدم على خش في الكومبيتيشنز.
تمام.
تمام. لان الكومبيتيشنز مهمه. تعال نشوف الاي جي يو فروم. بص عليها. طيب اوكي في عندك
هو انا ما زلت عادي بطلع الداتا اللي كذا، يعني خلصت بتاع الناشونال نورث كارولاينا، وحاليا شغال في الميسين بقى قربت تخلص. هي بس اللي عطلني في النص ان جيت انزل الداتا من على من على الجزء بتاع اليو اس جي اس. بقى كنت بدخل بلاقي الخرائط مش موجوده، بتيجي ايام كده ما اعرفش عشان أنا بنزل كتير ولا
يبقى في
ايه.
سيرفر او حاجه.
حاجه زي كده، يعني مثلا امبارح ما كانش فيه ولا حاجه على على
الديجيتال فيجن ماب.
النهارده دخلت لقيتها موجود، فرحت نزلت بسرعه المسيسيبي، وحاليا برنامج.
هي غالبا بيبقى سيرفر ايشيو.
هي ده اكيد يعني.
طيب
حتى دلوقتي جيت انزل الستيب
بس
تاني.
بينزلوا صغيرين صح؟ بينزلوا قطع
اه
صغيره انت
بينزل.
بتعمل لها ميرج، بتعمل
اه
لها موزيك ولا
بعد بالظبط كده بعملها
على
موزيك.
الجي اي اس ولا
لا
بالبايثون؟
بالبايثون. هي الخطوات بعمل لها
تاخد
موزيك.
وقت.
لا كل الخطوات لحد، والله انا عايز اقول لحضرتك
ايه اكتر خطوه بتاخد وقت في الكومبيتيشن؟
الخطوه اللي بتحول فيها اللي هي بتبقى خلاص عملت النقاط وعملت الاي دي دبليو اللي هي الجزء بتاع الانتربوليشن. تيجي بقى الجزء الثاني اللي هو انت بتطلع الفلات دي، بتطرح ده من ده، وبعد كده تيجي ترجع تاني تعمل قطه للاجزاء اللي الاول اقل من اكتر من الزيرو. بعد كده تعمل قطه تاني للاجزاء اللي جوه الفلاد اريا اللي موجود. اكتر خطوه بتاخد وقت هي الجزء بتاع الفلاد اريا ده اللي بيقطعها بريزوليوشن عالي. بس برضو هرجع اقول ان لو الكود ماشي، لو الخريطه مظبوطه بتبقى كويسه. يعني مثلا من السيباتي انا بادئها مثلا من الساعه 8 الصبح،
مفيش اي مشكله
ما
فيها.
فيش اي مشكله، الكود كله ماشي شغال، ممكن تخلص مثلا على النهارده المغرب ولا حاجه. يعني كوني السيل بحالها خلصت. والنورث كارولاينا على فكره برضه ما
كان
عملش
فيها
حاجه.
مشكله.
هي اكتر واحده عملت مشاكل كبيره كانت فلوريدا الصراحه،
فلوريدا.
لان كلها
هي
كوستال.
فلوريدا اصلا كلها على ميه.
بالظبط.
فكلها
فمليانه نقاط كتيره كتيره
انا على ما
كتيره.
اعتقد حتى الستيتس اللي هي الداخليه مش هتلاقي فيها اي مشاكل.
ده
يعني
حقيقه.
مثلا كولورادو، تينيسي، كنتاكي، لان ما فيهمش ريفرين، ما فيهمش الحاجات اللي موجوده في الستيت الكوستلز.
تمام. هي ده صح. هي المشكله الكبيره لما بيبقى عندي مثلا ستيت وعامله كده، مثلا في كاونتس كتيره في فلوريدا كانت عامله كده. يعني تلاقي النقاط اللي جواها حتى لو دخلت على الموقع هتلاقيها مليانه كده. فدي بتولد لي عندي نقاط كتيره، وعشان تعمل كروس تاني على او تعمل كليب تاني للمناطق دي بتاخد وقت كبير جدا.
هو ده اللي بيأخر الكود. غير كده يعني لو انا عندي اريا كده كلها على بعضيها ومقفوله على بعضيها مش
مم.
هتاخد اي وقت.
مم.
هو ده اللي بيحصل في الكاونز اللي انا شغال عليها دلوقتي،
مفيش حل
بتخلص
فيها
بسرعه.
للحاجات اللي هي دي ما فيهاش حل، ملهاش حل كومبيوتيشنال.
والله ليها حل انك تقلل الريزولوشن بتاعتها، بس انا يعني الحمله خلصت، يعني الفلوريدا كده كده خلصت.
طب كويس.
يعني بس هي برضو الفلوريدا هرجع اقول ان في الاغلب الشغل اللي هنطلعه باللي هي ال 100 يير فلودنج،
مم.
لان دي فعلا هي الاكوريت. التانية اكوريت اللي هي ال 500 بس للاماكن اللي مش كوستا، اي مكان مش كوستا هي اكوريت.
طيب
الحاجه
مش
اللي
دي اللي هي
انا
الفي زون، اللي هي انت مطلع في
لا،
زون
الفي اي زون والفي زون دي اللي هي بتاع الكوستا، هي دي.
مطلعها صح
مطلع.
لوحدها؟ يعني انت مطلع في ومطلع ايه ومطلع اكس
ولا الاكس، لا الاكس مطلعها
500.
اللي هي لما بتبقى في جزئين في الاكس، لو الاكس اللي هي بقيه
مم.
الكون كلها، والاكس اللي هي بوينت 2 فلودنج
0.2%.
بوينت 2%.
مم.
البوينت 2 دي هي اللي انا بطلعها،
مم.
لان هي دي اصلا اللي ظاهره على الخريطه يعني
طيب ما هي دي 0.2%
البوينت
معناها
2%
500 year.
دي اللي انا عاملها.
طيب
شو-
طب كويس.
هو ده الجزء بتاع البوينت 2 ده، انا كل الفكره ان انا مثلا عندي دي مثلا مساحه الاي اي،
مم.
بره ده كله الاكس.
مم.
هو بيبقى عامل لي تاني على الخريطه او الشيب فايل اللي معايا، بيبقى فيه نقاط كده حوالين ده، قايل لي ان ده الاكس بس بوينت 2. انا بعمل ايه؟
ما هي الاكس هي البوينت دي.
لا، الاكس هي بوينت 2 على الموقع اللي هو بيطلع لك الماب، لكن في الشيب فايل لا. في الشيب فايل بيجيب لي حتى الاماكن اللي بره بقيه الكون دي كلها اكس.
500.
بالظبط كده.
طب ما انت بتعمل ايه؟
باجي احيشهم بقى، باجي اعمل لهم فلتر
ازاي
على
بتوصل لهم؟
بقى كل ده على
هو
على
مديك
الفايل.
الباوندري ولا مش مديهولك؟
الباوندر
يعني
اطهار.
هو قايل لك ال 0.2% والاكس
بالظبط.
مختلفين؟
عن طريق فيلد تاني اسمه سب تايب. يعني في
امم
فيلد للفلات زون وفي فيلد للسب تايب.
فهمت.
انا عن طريق السب تايب ده باجي عامل لده، باجي شايله ويفضل لي بس ده. عشان اشتغل بقى على الزون دي كلها باجي اعمل ايه؟ اعمل ميرج دول مع بعض، واجي بدل ما اخد النقاط جوه باخد النقاط بره.
كويس. طيب تمام، حلو الكلام ده.
ده بالنسبه للفلودنج اريا.
طب بقول لك، هل هتقدر بعد ما مثلا تخلص هتقدر تعمل لهم زي اب او حاجه بحيث انه يبقى سيرشبل؟
هقول لحضرتك على بقى. انا النهارده لما قريت في الجزء بتاع الناتشورال هازارد اندكس ده، لقيت ان هو باني الاي ال بتاعه على 3 حاجات: الاكسبوجر والانوال
اه
فريكونسي والاتش لوس دي اللي هي الهيستوريكال لوسز. في الاغلب دول احنا مش هنعرف نيجي جنبيهم، دول تمام لان هم عاملينهم.
مم.
دي هي اللي عنده فيها مشكله. ليه بقى؟
ليه؟
لان الاكسبوجر هو عامله على اساس، طبعا هو مش مطلع خرائط زي ما احنا عاملين. هي كل الفكره ان خد الزون بتاعته اللي هو شغال عليها، مثلا السنسز بلوك او السنس تراك،
مم.
وشاف لو بتعمل انترسكت مع الجزء اللي على الخرائط اللي موجوده اللي هم عاطينها لنا بتوع الفيما، خلاص اذا دي حصل لها اكسبوجر، وخد ال 100% ان هي خلاص هتتدمر كلها.
مم.
طبعا احنا عندنا ما بنعملش كده، احنا جبنا هازارد ماب،
مم.
وعلى اساسها نقدر نقول ده مش ستيت 1 3
مم.
لحد 4. فانا الجزء ده هو اللي هيبقى الايدج بتاعنا احنا،
مم.
ان هو بدل ما هيبقى 100% لا هتبقى نسبه معينه.
مم.
يعني هنا بيعتبر ان المبنى كله اتدمر حتى لو الفولاد اللي موجود عنده 0.1
الاكسبوجر.
الاكسبوجر. يعني لو دخلت انا ممكن اوري حضرتك الحته دي فين في الفايل.
خش على ده.
ليرن مور في تكنيكال. لا مش الداتا، في اللي هو ده تكنيكال الناشونال اندكس تكنيكال دوكيومنتيشن. هتلاقيه في صفحة مثلا 200 حاجة و50 256. ده هتبقى لأن هو في الجزء بتاع الفلودنج أنا اللي هو ريفينيو فلودنج. هي هنا ناخد الداتا بتاعت الكوستال فلودنج والريفينيو فلودنج. أنا جبتها هنا هوريها. أيوه هي 17 دي الجزء بتاع الإكسبوجر. أيوه
هو بيعتبر الاكسبوجر ده هو اي حاجه متعرضه للفلود.
بالظبط، هو كل الفكره ان احنا على نفس الخرائط اللي احنا اشتغلنا عليها دي
0 1 ولا بيديها ليفل معين ولا
0 1. يعني هو كل الفكره انه بيدخل انا عندي خريطه مثلا نفس الداتا اللي
بس
احنا
هو ده
شغالين عليها.
الاكسبوجر. هو الاكسبوجر انت متعرض للفلود، vulnerability انت متعرض قد ايه.
ما هو ما بيدرس يعني ملوش دعوه بالفولنربيلتي خالص، هو بيدرس
الفولنربيلتي هو مطلعها في
السوشيال.
في اللوسز، فيها السوشيال وفيها فيزيكال vulnerability. ما هو بص دلوقتي هو الريسك كله عباره عن ايه؟
مهم.
عباره عن hazard، exposure و vulnerability. تعال نقول الهازارد ممكن يحصل او ما يحصلش، فليه
صح.
probability of occurrence. طب هو لو حصل يا اما هتبقى exposed يا not exposed، يا اما 0 or 1.
مهم.
انت ممكن ما يبقاش عندك damage but you are still exposed. يعني الفلاد لسه حواليك، خد بالك حتى لو انت مش flooded انت still exposed. في ميه حواليك، في ميه في الطريق، في ميه حوالين البيت، ده still is considered exposure وبي affect اللي هو الريزيلينس اندكس بتاعك.
مهم.
ماشي طيب. طب تعالى بقى لو انت exposed هنشوف بقى انت vulnerable قد ايه physically و socially و economically. physically انت ممكن تكون exposed والفلاد حوالين البيت بتاعك بس ما فيش نقطة مية دخلت البيت بتاعك، فالفيزيكال vulnerability بتاعتك زيرو.
مهم.
social vulnerability انت اللي عارف تتحرك بالعربية، هو ما فيش فلاد داخل البيت عندك بس المية بره حوالي 1 فيت، ما تقدرش تحرك العربية، ما تقدرش تمشي في الشارع، مش قادر تروح المستشفى، مش قادر تودي عيالك المدرسة، مش قادر تروح الشغل. بيأثر على السوشيال فولنربيليتي بتاعتك. لو انت مش قادر تروح الشغل، مش قادر تشتري اكلك، مش قادر تروح تجيب بنزين، كل البيزنسز هتتأثر. عمالة بتلوز كاستمرز، عمالة بتلوز امبلويز، بتلوز ليبر، لان انت هتخسر شغلك لان انت مش هتروح الشغل. ما هو البيزنس هيخسر الامبلوي بتاعه.
مهم.
مش هتقدر تروح تشتري من الجاس ستيشن من السوق، فالبيزنس بيخسر الكاستمرز بتوعه. بنسميه ليبر وكاستمر ريتنشن.
مهم.
لما بيحصل ناتشورال هازارد بنشوف الليبر ريتنشن قد ايه، لان الليبر هو بيشتغل يومي او بيشتغل شهري. في فلات انا مش رايح الشغل، انا اروح على الشغل اعمل ايه؟ فبيخسر الليبر بتاعته وبيخسر الزباين بتاعته، فبيخسر كل ده، فبيأثر عليهم ايه ايكونوميكلي. فكل دي حاجات. فهو ممكن من وجهة نظر لان هو بيطلع الانيوال لوس. انت عارف الانيوال لوس بتتحسب ازاي؟ الانيوال
مهم.
لوس مش بس مبنيه على 1 او 2 ريتيرن بيريد، مبنيه على سيريز اوف ريتيرن بيريدز. باي ذا واي ده كان one of the questions اللي جالنا من بتوع الانشورنس لما احنا قلنا ان احنا نطلع انشورنس بريميوم باستخدام فاكر انت في الوين دامج والكلام ده، لما احنا عملنا برزنتيشن في البروجكت بتاع ويب سنتر.
مهم.
كان في سؤال وده كان تريكي شويه، لان هو قال لك ايه، احنا قلنا هنروح بعد الايفنت ونطلع صور وده هيهلب اس ان احنا ناسس البريميومز والكلام ده، وكان السؤال ده صح فعلا. ان هو بيقول انت ازاي هتجيب لي بريميومز مبنيه على اكستريم ايفنت؟ الاكستريم ايفنت مره بيحصل كل سنه،
تمام.
انا عايز
نعم.
الايفنتس الصغيره والايفنتس الكبيره وكل الكلام ده عشان ابني البريميومز بتاعتي. لان احنا ما بتبنيش بريميوم على سمول ايفنتس،
صح.
بتبني البريميوم على كل السيريز اوف ايفنتس اللي ممكن تحصل خلال ال 100 يير
مهم.
او خلال ال 1000 يير. تمام. ففي ايفنتس قويه جدا بس البروبابيلتي بتاعتها قليله، وفي ايفنتس ضعيفه بس البروبابيلتي بتاعتها كبيره.
مهم.
فبالتالي لازم بتاخد الافريج انوال لوس بيعتمد على كل الايفنتس دي.
مهم.
فهو مطلعين كل الكلام ده في الافريج انوال لوس. يعني انت لو رحت هنا هتلاقي الافريج انوال لوس، اكسبكتد انوال لوس ده لوحده، السوشيال فولنربيليتي ده لوحده، الكوميونتي ريزيلينس ده لوحده. فهو انا مش فاهم بقى هو استخدم الاكسبوجر في ايه، تو
هو
كالكوليت ايه.
هو بياخد الاكسبوجر ده. هو
اها،
هنا الاكسبوجر ده هو اصلا الرقم الفلوس.
اللي هو الاكسبكتد انوال لوس.
لا، ما هو ده لما بيضرب الاكسبوجر في الانوال فريكونسي بتاع الحدث ده، هو خد 20 سنه او مش عارف كام، 22 سنه حاجه زي كده، وشاف عدد الحدث ده بيحصل فيها الفلودنج مثلا بيحصل قد ايه في ال 22 سنه دول، بيقسمهم عليها كده جاب الانوال فريكونسي. بعد كده بيجي بمعادله معينه كده بيجيب الهيستوريكال لوس. دي بصراحه انا مش قادر
اللي قصدك
افهمها قوي.
هو بيحسب الانوال لوس باستخدام المعادلات دي.
بالظبط.
مم.
الاكسبكتد انوال لوس هو لا، هو بيضرب الثلاثه دول في بعض جاب الاكسبكتد انوال لوس. عشان بقى يجيب الناتشورال هازارد اندكس بيضرب الاكسبكتد انوال لوس
ايوه فاهم
في
الكلام ده.
دي
بس
اصلا يعني مش نسبه، انا كنت فاكرها نسبه
هي
فطلعت فانكشن.
معادلات.
هو شرح بيقول ان مش عارف ليها مينيمم وماكسيمم يعني حتى
هقول لك مين اللي فاهمها بتوع الستارت اب، عشان كده انا عايز اقعدك معاهم في ميتنج، لان هم احنا دخلنا في الموضوع الفانكشن ده كتير.
مهم.
فعملناه اوريدي، يعني احنا اوريدي معانا الداتا والفانكشن معمول لها كودينج وكل الكلام ده.
طب خلاص، ما
فاحنا
هو
ممكن
لو دي
نستخدم.
معانا ممكن نستخدمها هنا دايركت.
تمام، بس عايزين احنا، انت عارف عملنا ايه في الانوال لوس؟ لان احنا عملناه لامبرتون بس، يعني عملنا نفس الموديل ده لامبرتون بس باستخدام اللوسز بتاعتنا. عملنا هيدرودايناميك موديلز لامبرتون حوالي 10 موديلز، 1 year 2 years لحد 1000 year،
تمام.
وجبنا لهم الافريج انوال لوس. ما اعرفش اذا كان هنقدر نعمل افريج انوال لوس هير، بس مش لازم. احنا ممكن نستخدم ال 100 year كريفرنس ايفنت يقول لنا الريزيلينس اندكس بتاعت الكوميونتي دي في ال 100 year شكلها عامل ازاي. مش افريج، مش افريج 1 اللي هي بيزد على ال 100 year anyway. بس خلينا نفوكس ان احنا نخلص الدامج. بس انا هشوف. انا كنت بكلم فين النهارده بتاع الستارت اب عشان اكلمه في الموضوع ده، بس مش عارف اجيت هولد اون هيم. وانس ان
تمام.
انا اكلمه ممكن نعمل ميتنج ونشوف ازاي نمرج الكلام بتاعهم مع الكلام بتاعنا.
تمام.
تمام.
بس هو حضرتك بتقول الانوال فريكونسي تاني كده عشان ما فهمتش الحته دي.
الافريج انوال لوس دلوقتي، انت عندك مثلا ايفنت ال 1 year هيطلع لك لوسز مثلا $1000. ايفنت 2 years هيطلع لك لوسز مثلا 3. ايفنت 50 هيطلع لك لوسز اكبر. 100 هيطلع لك اكبر. 1000 هيطلع لك اكبر. ماشي. للاسف بتوع الانشورنس ما عرفوش. باي ذا واي، انت ممكن ال 1000 year ايفنت ده ايفنت بيحصل مره كل 1000 سنه، ممكن يحصل دلوقتي،
ايوه.
بس التشانس بتاعته 0.001.
مهم.
تمام، 1 over 1000، بس ممكن
يحصل.
يحصل. وده ممكن يحصل دلوقتي، كلهم ممكن يحصلوا. فاحنا بنشوف الافريج انوال بتاعهم قد ايه. فعشان كده انت بتقوم انت واخد اللوسز والافريج انوال لوسز بيساوي 1 على الفريكونسي بتاعة الهازارد مضروبة في اللوسز بتاعته.
مهم.
فانت كده بتافرج كل الكلام ده. يعني انت بالظبط بتقوم تمسك الايه، يعني مثلا ده هيطلع لك $1,000,000، تقسم المليون على ال1000 هيديك الافرج كام؟ $1000.
مهم.
انا جيت لو بصيت هنا اللي هو 1 year بيطلع لك $1000، فتقسم 1000 على 1 يطلع لك 1000.
ألف.
ففي الاخر انت بتافرج الكلام ده على كل الييرز.
تمام.
هو ده اللي هو 1 over the frequency. 1 over the frequency اللي هو البروبابيلتي بتاعت الايفنت
تمام.
او return period اللي هو دي
طيب.
ريتيرن بيريد اللي هي 1000.
تمام.
مهم.
الفكره ان هو هنا، طب ما هو هنا مطلع رقم في الداتا نفسها، يعني هو عاطي له رقم لكل كوني
مم.
انوال فريكونسي.
طب الايكويشن دي
الكويشن دي هتلاقيها موجوده في الفلادنج برضو، الجزء
انا شايف الفريكونسي بيقول لك event day count period.
دي الفريكونسي. المعادله نفسها بتاعت ده موجوده في السكشن 4 متهيألي، سكشن 4.
فين فوق؟
سكشن 4 المعادله نفسها موجوده في سكشن 4.
ده 17.
طب حضرتك اطلع فوق كده هنا في نفس الصفحه دي، اشوف بس هنا موجوده ولا لا. لا، فوق فوق كمان.
البي سي ال بي
ده
اس.
ده هو الفاليو بتاعي.
كل ده exposure spatial process.
يبقى موجوده في السكشن 4.
اوكي، فعارف اي حاجه نسيرش بيها؟
هي اي ال بس لا اكسبو اطلع لو هستنى السكشن صغير مش كبير. أنواع.
مم. only approximated average annual LRB loss.
لا، كل ده تحت. انا في الصفحه 300. ممكن حضرتك تطلع بس صفحه 50 او 40. ايوه.
expected annual loss. اوكي، بيقول لك calculation value. Expected annual loss calculated using a multiplicative equation that considers the consequence risk factor. What is the HLR?
اللي هو الهيستوريكال لوس ريشيو. دي لها حسبة كده هم
هم
حاسبينها.
بيعملوا تقريبا حسبة مختلفة عن المعروفة. exposure value of an area by the estimated annualized frequency. ده قلت كام 50؟
هو ده ما هو موجود فوق بس.
عشان ادوس على مستنى بس. طب معلش 5 دقايق بس، ماشي. exposure annualized frequency historic loss ratio. أنا معرفش الصراحة equation دي متصممة ازاي. انت محتاج to dive deep into it and because historic loss ratio. ايه هي الهيستوريك loss ratio؟ جابوها من داتا، جابوها based على modeling، وبعد كده analyze the frequency اللي هو قال لك بيحصل كام مرة في الداي، فده أكيد حاجة specific للداتا بتاعتهم. فاحنا ممكن نعمل اوريدي الحاجة بتاعتنا لو احنا عايزين. فانت ممكن تشوف ده بيقول بيعمل ايه، ونشوف احنا هنعمل ايه، واحنا لما نببلش نقول ايه الفرق ما بينهم.
ما هو الاتنين دول متوقفين على داتا هم استخدموها فعلا، يعني
بالظبط،
ده
موجودة
شرح.
الداتا. لا بس على ما اعتقد إنهم عاملين ببلش لداتا كتير.
ايوه انا عارف هي موجوده بس كتير يعني، وبعدين بتدخل بقى في
انت عملت
حاجات.
داونلود للداتا والداتا كبيرة.
يعني ده هم بيدخلوا على مواقع ويشوفوا الحاجات ايه اللي بتحصل اوريدي
طيب
بيعمل.
بس انا عارف ان الستارت اب ما دخلش في موضوع الاكسبكتد انوال لوس، ما دخلناش في الجزء ده، بس احنا دخلنا في الجزء ده اللي هو ريزيلينس والسوشيال،
تمام.
وطلعنا الافريج انوال لوس بمعرفتنا. فاحنا ممكن ما نحتاجش الجزء ده، لان احنا اوريدي بنطلع اللوسز بالفراجيليتي.
بالظبط، ما هو
ف
انا كل اللي كنت عاوز اقوله ان هنا هو المعادله دي كل اللي فيها حاجه ماديه هي القيمه بتاع الاكسبوجر. انا هبعت لحضرتك سيكشن بالظبط اللي بيقول
طيب
الكلام ده. ده الاكسبوجر ده هو بياخده هي القيمه بتاعت مثلا المبنى ولا حاجه.
خد بالك ان ده بيبقى اللي هم بيعملوه ده، دي اللي هو البصمه بتاعتهم. زي كل حاجه ليها البصمه بتاعتها. وبرضه الايكويشن دي انك تضرب في السوشيال على فانكشن في السوشيال والكوميونتي، دي البصمه بتاعتهم. انت ممكن انت تاد because that's index.
مهم.
كل واحد ممكن يكون بالاندكس بتاعه. يعني انا ما اعرفش الصراحه، لما شرحوا لي الموضوع ده ما اعرفش هم بيعملوا ايه. يعني
انا
سوشيال
عايز اقول لحضرتك هو ده هو كل
وكوميونتي.
الفكره ان يعني انا ما اعرفش برضه هم بيأسسوا على انهي حاجه، بس الايه هم عاملين حاجه اسمها تريانجل ديستريبيوشن. الايه هنا اللي هي اقل نقطه
اه
بوينت 5
بالظبط.
وهنا 2
بالظبط.
والمود هنا بواحد.
مهم.
بيحطوا هنا بقى يعني هو بيقول لك القيمه لو اقل من الواحد حط لها قيمه هنا. طب كام القيمه دي؟ لا ملهاش معادله. هو بقى ده ممكن
ممكن
يبقى،
راندم.
ممكن تبقى راندم، ممكن مش راندم، ممكن يبقى الشخص اللي بيحطها هو واحد بس اللي بيحطها وماشيين على
يعني
نمط
انا
واحد.
فاكر فيز وامير دخلوا في الموضوع اللي هو التريانجلر ديستريبيوشن وقعدوا يعملوه، بس انا صراحه ما دخلش دماغي يعني، بس ده اللي
و-
بيحصل.
سؤال.
خلينا نقعد معاهم ونشوف الدنيا فيها ايه.
تمام.
تمام. اوكي.
انا عايز اقول بس حضرتك ايه هي اللي كانت وجهه نظري، والحركه هتقول كده كده اللي هيمشي. بس انا كانت وجهه نظري ايه، احنا الحته بتاعتنا المختلفه عن كل ده هي الحته بتاع الاكسبوجر، او مش الاكسبوجر اللي هي الدمج.
الدامج
الدمج
بالظبط.
اللي احنا نطلع لكل مبنى اللوس ريشيو بتاعته.
بالظبط.
فهنحوش ده اللي انا كنت فاهمه. هنحوش ده ونحط مكانه اللوس ريشيو لكل بنت.
كمان خد بالك ان دي مش building level analysis، ده
عارف
هو
ازاي؟
داخل الكلام ده على اقصى حاجه census tract، فهو بيشوف frequency في السنسس tract، losses في السنسس tract.
اه.
فهو الداتا بتاعته مبنيه على bigger
ده انا هقول لحضرتك على حاجه، ده
course
هو
resolution.
الفريكونسي ده هو عاملها على الكوني كمان، ده هو واخد انهيرت ليها للسيستم بلوك والسيستم تراك. يعني هو هتلاقي في
يعني
نفس
هي county level resolution
كوني،
بالظبط.
وبعد كده راح قال لك ده بيساوي ده بيساوي ده.
مم.
ف
فاحنا ما احنا دي بقى الحاجات اللي هتبقى الارجيومنتس بتاعتنا، واحنا بنارجيو ايه اللي بيلاك في السيستم ده، وايه المشكله فيه معايا. فغالبا ده اللي هنتكلم فيه، هنقول ايه الويكس بوينتس بتاعت موديل زي ده، ان هو فيري كورس بيشتغل على الكاونتي ليفل، بيشتغل على كذا، واحنا الموديل بتاعنا ادفانسد في الاتجاه ده
تمام.
معايا. لان هو ده اللي احنا بنعمله. وعلى فكره ده اللي احنا عملناه في ريزولوشن في الستارت اب، عملنا بيلدينج ليفل اناليسيس، وبعدين خدنا السوشيال والريزيلينس داتا عملنا لها انتجريشن مع البيلدينج
دايركت
ليفل.
بالظبط كده.
تمام.
طب ايه الخطوه؟
الخطوه هنستنى لحد ما احنا ما نطلع الدامج. انا بس عايز اقعدك مع بن وامير عشان تفهم الجزء ده، او ناخده دايركت من
ما هو
الشغل.
ده اللي انا كنت عايز اقوله. هو ده انا حتى ممكن يعني حتى مش
لان احنا
هحسبه
عندنا
انا
الكلام ده على البيلدينج ليفل. يعني
لكل واحد من ده البيلدينج
كل
ليفل.
يعني عاملين الكلام ده بس احنا عملنا الكلام ده ازاي؟ هو دلوقتي عامل على السنسس تراكت، كل البيلدينج اللي بنفس السنسس تراكت هتاخد
تمام. القيمه
الفاليوز
اللي هي
دي
موجوده اهي، ده انا
بالظبط.
ممكن اعمل يعني ده خلاص،
لو انت
ما هي
بالظبط.
الداتا موجوده.
طيب
انا نزلت
كويس.
الداتا دي موجوده.
بس انت كاتب الفانكشن اللي بتلينك ما بين الداتا وبعضها، لان هو في فانكشن
بمعنى
هنا اللي هي فانكشن في السوشيال والايكونوميك، لان تقريبا في 7 بارامترز للكوميونتي ريزيلينس، انفراستراكشر ومش عارف هيلث
ما هو انا وجهه نظري في البيبر بتاعتنا الحته اللي فيها مختلفه ان احنا عملنا ايه؟
مم.
ان احنا بدل ما هو هنا بيستخدم بس حته اللي هو الترسكشن، لا انا رحت طلعت خرايط وده انا شارحها في سيكشن لوحديها. وبعد ما عملت خرايط استخدمت الفولنربيلتي اللي هي الفانكشن بتاعتنا. تمام. وبعد كده رحت طلعت بيها لكل بيلدينج اللوس ريشيو بتاعته، وبعد كده
تمام.
رحت دخلتها في المعادله بتاعتهم اللي هي مش مبنيه على الانسرتين. هنا ما فيش انسرتين في الموضوع ده غير في الجزء اللي هو بتاع السوشيال والريزيلينس والكلام ده. لكن الدمج اللي انا فاهمه، وده هرجع اتاكد منها، ان هو خد التوتال بيلدينج، الرقم بتاع التوتال بيلدينج، واعتبر ما دام حصل اكسبوجر خلاص يبقى البيلدينج كله ضاع.
مم.
لان هو ما جابش، هو هيعرف منين ان المبنى، او ما جابش سيره الفلات دبس خالص، هو قال يا فلادنج يا مش فلادنج.
طيب تمام، خلينا ماشيين في الجزء ان احنا نطلع دامج من ال 100 وال 500 يير،
خلاص.
وبعدين هنشوف ازاي نمرج الكلام دوت مع مع الجزء بتاع الدامج بتاعنا،
خلاص.
ونطلع الاندكس بتاعنا ونشوف هنعملها ازاي.
خلاص
تمام.
تمام
لان
ماشي.
انا كلمتك في موضوع اللي هو الريزيلينس انفورمد ريسك اندكس، حاجه زي كده، دي فاكر؟
اللي هي العنوان اللي ممكن يتحط يعني.
اها.
تمام، ايه ممكن يكون هو؟
resilience informed risk index. هو ريسك بس هو informed by resilience.
ريسك. ما يتغيرش الحاجه اللي ليها علاقه بالهازارد والدمج، لان احنا اوريدي زي ما قلت لحضرتك الايدي ممكن يبقى عندنا.
الريسك ده هو فيه دامج، لان انت بتقول دلوقتي انا بطلع ريسك، بس خد بالك كل اللي بنعمله ده مش دامج. احنا مفيش حاجه من الكوميونيتيز اللي احنا عملناها الدامج اوريدي حصل.
ده حقيقي.
احنا بنقول ده لو ده حصل الدامج ده هيحصل، فده بنقول عليه ريسك.
ده ريسك صح.
تمام. يعني حتى ميامي ديد كاونتي المفروض ما نقولش دامج، احنا
اه
بنقول ده ريسك، اللي هو ايه؟ ان لو الهurricane ده حصل
ممكن يكون دامج
الدامج ده
كفايه
حصل،
فوق السن.
فبالتالي لازم نبقى فيري سبيسيفيك. حتى اللوسز احنا بنستخدم دامج او لوسز لو احنا بننفستيجيت هوريكين الرابر 10 لامبر دامج، لكن لا بنفستيجيت دامج ان انا بشوف دامج حصل فعلا وبحاول اشوف ايه اللي حصل. احنا لما نطلع كاونتي عمرنا ما نقول دامج، دامج ده هتبقى كده، احنا بنقول ريسك. الريسك اللي هو ايه؟ الريسك ان الدامج يحصل.
تمام.
معايا؟ فخلينا ريزيلينس انفورمد ريسك اللي هو ايه؟ هو هنا في probability ان دامج يحصل، بس في ريزيلينس فاكتور ممكن تعادل تخلي الريكفري بتاع الدامج ده اسرع.
خلاص تمام.
تمام.
خلاص ماشي.
تمام alright.
اوكي.
اوكي. ابعت لي مصطفى لو هو لسه So how's everything?
Everything going good, Professor. Last week, I need to take my wife to the emergency. She
Oh.
had certainly bleeding, so that's why.
Oh,
Yeah.
so is she okay now?
Yeah, she's okay right now.
So how far she is in the pregnancy?
She's now 12 weeks.
12 weeks?
Yeah.
All right. All right, so I checked the paper. Have you been reading any papers recently? Checking, I told you like to start reading the papers because the thing is, from what I see here, like here, like still like we didn't get there. Like even in the writing, I asked you to do like some stuff and like the figures. So some figures are small, like some stuff that doesn't make sense. Like, okay, like me looking at this figure, all right, I see hazard module, exposure module, vulnerability module, loss and sensitivity, aggregation scenarios, uncertainty. So I feel it's what is the connectivity between these and what is this figure is doing? Like I believe there's a way, like even putting like when we write figures like this, I wouldn't put abbreviation like what is HWMS? I know it's high water marks, but who's reading is not gonna figure it out. DEMs. So unless you explain it so everybody can know. Same thing here. I know that you want to show hazard, but maybe like I don't know, make it a little bit bigger. The fonts are not matching. All these arrows are not in the same line. And model calibration and refinement, and then what? So you either make these on their own. So I feel like it's a random figure. And also here in the abstract, I don't know exactly what are you writing. Like you are saying, we present a multi-resolution framework. That's right. We are having a multi-resolution analysis. But the thing is, the idea is not the multi-resolution. The idea is to investigate the impact of the analysis resolution. Like you said, this study examines how the spatial and thematic resolution. I'm not sure if the thematic is the right word. I believe the modeling resolution of hazard, exposure, and vulnerability. And by the way, we didn't investigate the resolution of the hazard. So we didn't, that's the thing. I'm not sure. I know that I wrote the paper, but the thing is, I had a vision for this paper before that I'm gonna study hazard, exposure, and vulnerability, but you didn't. So if you didn't study hazard resolution, you shouldn't put it here. I told you if you want, you can do that. You can develop your own HICRAS model, and we do this a few months ago, like I don't know, in the summer or something. I told you if you want, you can develop hazard map, but you never learned it HICRAS, you never did anything, so it stays the way it is. So yeah, we have here hazard. No, we didn't do hazard. Only what we did is the archetypes. So maybe the modeling resolution in terms of the minimal archetypes, building archetypes used to model the vulnerability of the building. So that's how you pick your words. So that's why I'm telling you, you have to go through this paper word by word because that's research. We cannot. Because the thing is, I know you use the chat GPT in this whole thing. I use the chat GPT too, but I read every word. Every word that is written, I read it. Did I do it or no? Okay. So I have to read it. Did I did hazard model, hazard resolution? I didn't. I have different hazard models, but they are not at different resolution. They all at the same resolution, but for different return period. So that's not resolution. Resolution if you use digital elevation map with a high resolution, or you increase or decrease the mesh size. That's a resolution. Yeah, so a lot of stuff like this. Like here, I'm not sure what is you actually right. Integrate hazard representations from linear interpolation. We didn't do any linear interpolation from high water marks. I wanted to, like when I wrote this paper, I wanted to do that, but you didn't do it. So you have to take out the things that you haven't done. You understand what I mean? The paper has a lot of stuff like this. That's why You will not send me the paper and it's like, hey, review it and give it back to me. I was like, I'm not gonna write it for you. You have to give me a decent, reviewable paper that represent the actual work that you have done. But you will not give me a ChatGPT paper that, like, this is my own paper. I already wrote it. You are not gonna give it to ChatGPT and ChatGPT send you another paper and I'm gonna review it. You have to rewrite it back. You have to read every word. After you read every word and make sure that this represent your work, you send it back to me. And the thing is, you have to check if what you have makes sense or not. Okay? So same thing, the introduction. Like if you find some stuff in the introduction that doesn't make sense, you will have to remove it. Like for example, I didn't investigate the hazard. Right, let's go to the methodology. So hazard modeling at a diverse spatial resolution, we haven't done that. So that's what I'm saying. How would you put this, something that you haven't done? Do you think that we're gonna send it to the reviewer like this? I wouldn't. Like, that's why you have to write it from the first place. That's why I want you to read what you have and ask yourself a question. Did I do this work? Did I investigate different hazard resolutions? No, you didn't. Okay. Yeah. Several data sets. Okay, I know that you are trying here to explain the different resolution, so maybe you name the section multi-resolution framework and explain the archetypes. But the thing is, we didn't do hazard generation. I understand that here you want to show the steps that you did hazard, exposure, and vulnerability, but I believe there's a better way to do that. Look at the figures that I give to you. So hazard modeling, don't talk about any resolutions of the hazard because we didn't do anything about that. And I don't know why you have the Lumberton. I told you don't do the Lumberton here. Lumberton should show up in the case study. And this figure, I told you remove it. I don't know what is this figure is doing here.
You mentioned not to mention about case study.
So this is Lumberton. And actually, if I'm showing a figure to Lumberton, I'm not gonna take a screenshot from Google Maps having locations of stores and stuff. I don't know what is this about. Housing units, we don't need that here. So, and the thing is, you have so yeah, I ask you that you should read the papers that has case studies. For example, this paper, and see how I designed this paper. See how the sections look like. That's what I have been saying every time. Like here, introduction, and then methodology. Here, section number 2. There is nothing about Lumberton. Even this paper was for Lumberton. And then section 3 is going to be here, example community, Lumberton, North Carolina. And then you list anything about Lumberton. And look how I did it when I used the Google Maps. It was a clear map showing the boundaries, showing the rivers, everything can be seen. All right. and you are presenting losses in the methodology. We don't do this. That's why I'm asking you to read papers so that you know when to present results and when to put method and when to put equations, when to put algorithms. You have to separate. So the semester start like 2 months, and I have been asking you that you need to read papers so that you can write papers. If in 2 months you read at least 3 papers or 1 paper every 2 weeks, even that, like, you should read a paper like multiple papers per day. That's how you should evolve. So that's what I'm asking for. Read papers and see how's the paper's structure look like. And then look at your paper. Does it have the right structure? Like, okay, let's enable editing. And then let's see the headings. So try to have a headings and see the structure of your paper. What do you have? You should have an introduction. You should have methodology, case study, and results, summary and conclusions. That's how the structure look like. So try to give me the paper in a decent structure that I can review it, not like everything is everywhere, every figure is everywhere. And give it to me so I can review it. I can't review it that way. Because if I review it, I'm gonna write it from scratch. And I don't want to do that. Okay.
Is there any, I mean, every journal has different format, right, Professor?
Yeah.
So you want me to follow any?
The same journal like this one, severe. That's International Journal of Disaster Risk Reduction.
Do you have a sample? I mean, should I download the sample and put it like?
I think right now they might have different setting, but you can download the recent papers and see how they look like. Okay.
Okay.
All right. So that's it for now. Have you learning any new tools, machine learning,
Yeah.
programming, anything?
Last week I couldn't able to, but
Mhm.
I was going with the learning process
Mhm.
of the machine learning.
Okay.
So
Sounds good.
is it possible if you give me any, I mean, if we can develop our work also in machine learning, can I give you an update like this?
That's what I want.
Okay, awesome.
Okay.
Sure. Thank you.
All right. Thanks. Have a good day.
Hello? Hi, Diego, how are you?
Can you hear me?
A little bit.
Oh, sorry. Okay, what about now? It's a little bit noisy here.
Yeah, I can hear you now.
Okay, perfect. Awesome. Go ahead.
If you want, you can call me on my phone if it's much better.
Sure.
Do you have my phone number?
What's your phone number?
970
970
214
214
4716.
4716. So 970 214 4716.
Yes.
I'll call you in a second.
All right. Okay. Bye.
Yeah, sorry about the professor. I'm changing my phone.
No
So
worries.
I'm having problems. Phone number right now.
Sure. No worries. Yeah. Tell me what you have.
So basically, I was reading the requirements to graduate, and it's either 10th class and the class of project, or the 9th class of the engineering project.
Uh-huh.
So I'm interested in the 9th plus engineering project, and I want to present the concrete as my engineering project.
You want to present what?
The concrete competition from ASC. ASC hosts a concrete competition in which the students need to design a lightweight concrete that floats.
Okay.
And that's like one of the biggest competition on ASC. FIU has been participating in this competition since 10 years ago, and I'm one of the project managers right now.
All right. So, what is gonna be my role in this?
I don't know. Dr. Shia asked me, Dr. Yin asked me to contact you to be my advisor in this project engineer class.
Well, I can, but the thing is, the lightweight concrete or these stuff, it's more materials, not a structure. I can definitely add a feedback. I have background, but I mean like not as advanced as, for example, Dr. Limfley that he joined the department in the materials. But anyway, I believe I can help you as much as I can, but I'm not sure is this is gonna be pass or fail, or is that like gonna be satisfactory, unsatisfactory? I don't know how this is gonna be.
Yeah, my understanding.
So this is gonna be like a 3 credit class, like supervised.
It's gonna be a 3 credit class, and I need my advisors and 3 more professors
Hmm.
read a paper and a presentation, and it needs to be approved by all the professors for the class to be passed. I think
Okay.
it's a 3 credit course.
Well, all right. I believe I can do that.
So I just want to like request permission. Sure. Do you need anything from me?
I don't know, like you need to figure out the paperwork and send me whatever papers that I need to sign.
Sure, sure, sure. Like as of right now, I have a concrete because I've been working this since June. I have a concrete that can support 1,800 PSI in 7 days, which will be around 1,700 PSI. But 28 days, that's the calculations. And the next 61.2. So basically, I have concrete cylinders that can resist almost 3,000 PSI. So that's been my investigation to put it that way.
All right.
Well, I would really like the entire process of the investigation, building the canoe, the design of the canoe. So all this process of making the canoe happen and taking it to the competition, the AC competition. So let me try to find out what we need.
Sounds great.
Okay, thank you. Yeah, of course, because if I'm dedicating like this amount of hours because I've been working on it, I would like to be able to present it to the university as my project, as my graduation project, call it that way, my engineering project.
Okay. But the thing is, as far as I remember, they used to do seminars to for students. I don't know. Like you basically make a research topic and then you do a seminar and then you will be done, you know. But I don't know.
Yes,
But this is gonna be a project. That's the difference.
yes, the seminar is 0 credits, but the engineering project is a total of 3 credits.
Okay.
It's kind of a meeting with Dr. Dr. Xia. Dr. I forgot her name, the advisor, the master's advisor professor.
Okay.
Dr. Yeah. And that way we can like understand a little bit more, but basically I think I need my advisor, my graduate advisor, plus 3 professors more, my graduate professor,
Sounds great.
present the project. Okay, perfect.
Okay.
Perfect.
Sounds good.
And
Thank
then we
you.
try to set up with Dr. with the advisor with Dr. Yeah, Dr. Yin.
Okay.
Okay, perfect, professor. Thanks so much
All
for
right.
your time.
Sounds good. Thank you so much.
Bye.
Bye.
Interesting. How is the fire didn't make it to the room?
لا يوم يخلص ولا يوم إلا بلقاك يا حبيبي صحاك الشوق منه. Running out of hot water?